Ja. So, hi, jetzt bin ich doch live. Jetzt, wo Elon kommt, machen wir das mal. Hi, Elon.
It's good to see everyone. It's a little hard to read the room with everyone being in cars, but it's it's the only way we could do it. So hopefully it's cool, and hopefully you can hear me. Can you guys hear me?
Yeah.
Okay. All right, great. Well, thanks for coming. I think it's been an incredible year, and I'd like to thank you for your support through tough times, good times. It's been great. Really appreciate everyone who's put their hard-earned money into Tesla, and I think it's worked out pretty well. This has been a good year, and I think there's many good years to come. So I'll go through the sort of the shareholder presentation, I think, fairly quickly because
Prost an alle, die schon da sind. Das wird ein geiler Abend.
So, really, I'm just going through a recap of what's happened over the past year or so. I think starting from in terms of our ability to create a factory, huge kudos to the Tesla Shanghai team for being able to go from literally a dirt pile to volume production in 15 months. It's like, damn. Yeah. So, and I think something that's really quite noteworthy here is Tesla is the only foreign manufacturer to have 100% owned factory in China. So this is often not well understood or not appreciated, but to have the only 100% owned foreign factory in China is a really big deal, and it's paying huge dividends here. So we really wouldn't have the results that we have had this year without the great efforts of the Tesla China team. So I'm super appreciative of that. And we'll see the Shanghai factory continue to scale quite a bit from where it is right now. I think we really could expect that to be, over time, a factory that produces over 1 million vehicles a year.
Wow. Ja. Wir werden den Shit rocken hier.
So,
ja.
Let's see. So we also reached in the past year volume production of the Model Y, and this was the smoothest launch that we've ever had. So I think we're definitely getting better at new vehicle launches and building factories and scaling production. As you've heard me say before, it's the hardest thing is scaling production, especially of a new technology. It's insanely difficult. Making a prototype is relatively easy. And if I think of, like, what is the real achievement of Tesla in sort of car company terms, it's like it wasn't making sort of exciting prototypes. It was that Tesla was really the first company in about a century in the U.S., the first U.S. company in the U.S. to reach volume production and be sustainably profitable. Like, the crazy thing is this has really not happened in 100 years. That's the actual super hard part. And we now have 4 vehicles in volume production, S3 XY. So also the toughest joke, I think, maybe ever. It was a very difficult joke to make. So we also introduced the lowest cost solar in the U.S. It's only $1.49 a watt. And we really simplified the whole value chain. So reduced sales and advertising. We got rid of a bunch of unnecessary costs, and really are just relying upon the fact that it's just the lowest cost, most efficient solar in the U.S. Providing both retrofit and the solar glass roof. Which I think is a really great product, a hard product to make work, but it will be a major product line in the future. And we also got 4 consecutive quarters of GAAP profitability, which was very difficult. Yeah. So, and so a testament to the hard work of people at Tesla. I mean, to do this in extremely difficult times against a wide range of adverse circumstances was insanely hard, but we got it done. So, and I think the future's looking like I think it's very promising from sort of an annual profitability standpoint.
Oh, der Ton ist zu leise, warte.
In order to achieve, in order to sort of do well financially, you really need economies of scale, and you need ideally the best technology. And I think we had the best technology for a while, but now we are also achieving economies of scale. So, and we're also rapidly improving autonomy, which is a massive value add to each car. So, I think the value of Tesla is going to be like total, just on the vehicle side, total vehicles produced times the value of autonomy. That's a way to think about the future value of Tesla. We also have consistent free cash flow generation. This is really important for growth. And a key element here is tightening up the time from when a car is ordered to when it is built and delivered. So for a company that's growing rapidly,
Ich habe es jetzt gerade lauter gemacht, also jetzt müsste der Ton, ja genau, ihr schreibt es jetzt gerade. Es ist halt immer 20 Sekunden verzögert, deshalb, ja.
And if you can do that inside the sort of your kind of payables timeline, then the faster you grow, the more cash you have. Or conversely, if you're unable to do it within your payables timeline, the faster you grow, the less money you will have, which is obviously bad. It's for a capital-intensive situation. So just tightening up and having the parts move very quickly to the factory, put it in a car, get it to a customer, makes a massive difference to cash flow generation. And I mean, that's why it's extremely important to have a factory in each continent. Because if you don't at least have a factory in the continent, it is impossible to achieve this. So having a factory in China that's able to serve China, and then soon many other countries in the region, will be key to us tightening that total sort of chain of cash flow and getting it, essentially the faster we grow, the more cash. This is really important. That's also why it's important to have Giga Berlin complete, because then we'll have a factory in China, factory in the US, and soon a second factory in the US in Austin, and a factory in Europe. And I mean, even if for Giga Texas in Austin, even if we had exactly the same costs as in California, it would still be advantageous to do it there because it's roughly 2/3 of the way across the U.S. So in terms of delivering cars to the central U.S. and to the East Coast, it's just faster, costs less, and it fundamentally improves our economics. So I think this is also maybe something that's not fully appreciated of just how important it is to have a factory at least on the continent or reasonably close to where the end customers is, so you can tighten that whole chain. Industry performance. We've while the rest of industry has gone down, Tesla has gone up. I think this speaks to thanks. And so I'd like to thank all the customers for taking a chance on Tesla and buying our product, and really hope you're enjoying it. This is really, our sales, as Al was saying, really grow by word of mouth. So this is really, I think, a very pure, it's very pure in the sense that it's like, it's growing on the basis of existing owners recommending it to new customers. This is really, I think, a good way to grow. And then in 2019, we had 50% growth. And I think we'll do really pretty well in 2020. Probably somewhere between 30 to 40% growth, despite a lot of very difficult circumstances. I mean, there's so many, pandemic, wildfires. It's like a whole bunch of difficult production issues. But thanks to the hard work of the Tesla team and a lot of innovative approaches to overcoming issues, we're able to still see significant growth in one of the most difficult, in fact, I say probably the most difficult year of Tesla's existence. So, and we also published our extended impact report. At Tesla, we try very hard to do the right thing. If right thing does not happen, it's just because we maybe made a mistake or weren't aware of it. But we always try to do the right thing as to the best of our ability, and then we publish the extended impact report to show, just a sort of a self-examination of, okay, what are we doing right? What are we doing wrong? What can we do better in the future? We're definitely trying to accomplish the most good. And so, if we occasionally make a mistake, we work quickly to fix it and do the right thing. So, it's worth looking at like the average life cycle emissions in the U.S. And just how much better a Tesla is or an electric car than any other than any kind of gasoline car. And what we'll talk about in the battery day is also just how much the grids around the world and actually, especially in the U.S., are greening. It's actually much faster than I think people realize. The U.S. is moving towards sustainable energy. And so as we move more and more to sustainable energy, then effectively you end up building the solar factories and the car factories themselves with solar. Over time you do, or with sustainable energy. Over time you'll even mine with sustainable energy, and eventually it will get to an effective emissions of 0. So that's where things will end up. Yeah. So we also have safety at the core of our design. The Tesla cars are the safest cars ever designed. We have the lowest probability of injury of any cars ever tested by the U.S. government, and that's just passive safety. When you add active safety into that, it's even better. So it's really, if safety is important to you, which obviously it is, the safest car you could drive is a Tesla. So I think some people aren't aware of this, but it's really, safety is paramount. It is actually the #1 design objective when we build a Tesla is safety. Our factories are also becoming safer, and if you look at the sort of accidents per total vehicle made, it's dramatically better than in the past, and it's already better than industry average, and we're confident we can get it to the best in the auto industry. Autopilot functionality continues to improve, and you can see it in the safety report that we publish every quarter. It's just getting better and better. The U.S. average for collisions is at roughly 2.1 per million miles, and with autopilot engaged, it's 0.3. I mean, this is a profound difference. It really massive, and this will get even better. So we're confident that over time we can get the probability of an accident, especially the probability of injury, to 10 times better than the industry average, like an order of magnitude better. So that's just a lot of lives saved and a lot of injuries avoided. So that's a huge priority for us. And on the autopilot front, I think it's kind of hard for people to judge the progress of autopilot. Like I'm driving. I as a matter of course, I've always done this. I drive the bleeding edge alpha build of autopilot, and so I sort of have insight into what is going on. Previously, about a couple of years ago, we were kind of stuck in a local maximum. So we were improving, but like the improvements kind of started tailing off and just not getting where they needed to be. We were quite close to still getting trapped in a local maximum. And so we had to do a fundamental rewrite of the entire autopilot software stack, and all of the labeling software as well. So we're now labeling in 3D video. So this is hugely different from previously where we were labeling essentially a bunch of single images from the 8 cameras, and they would be labeled at different times by different people. And some of the labels, you literally can't tell what it is you're labeling. So it basically made it sort of in some cases impossible to label, and the labels had a lot of errors. Now, with our new labeling tools, we label it in video. So we actually label entire video segments, and the system. So you get basically a surround video thing to label, and with the surround video and with time. So it's now taking all cameras simultaneously, and looking at how the images change over time and labeling that, and then the sophistication of the neural nets in the car and the overall logic in the car has improved dramatically. I think we'll hopefully release a private beta of Autopilot, of the full self-driving version of Autopilot, in I think a month or so, and then people will really understand just the magnitude of the change. It's profound. So
ja, das hat er schon oft angekündigt, aber so langsam wird es vielleicht mal wahr.
But because we had to rewrite everything, labeling software, just the entire code base, it took us quite a while, and the sort of new sort of, I call it like 4D in the sense that it's 3 dimensions plus time. It's just taken us a while to rewrite everything, and so you'll see what it's like. It's amazing. Yeah, it's just clearly going to work. Tesla core competencies. We've got engineering, obviously. But also manufacturing. I think manufacturing is underappreciated in general, and the difficulty of designing the machine that makes the machine is vastly harder than the machine itself. So, the designing, like making a Model 3 or Model Y or Cybertruck prototype is really quite trivial compared to designing the factory that makes it. Especially if it's new technology and you want to use new manufacturing methods, it's just at least 10 to 100 times harder to do the factory than the prototype. And that's why you see a lot of companies out there or startups, they'll bring out a prototype, but they just can't get it over the hump for manufacturing, because manufacturing of new technology especially is the hardest thing by far. Like basically the prototype is at best 10% of the difficulty and probably closer to 1%. And then software. Tesla is both a hardware and a software company. So a huge percentage of our engineers are actually software engineers. And you can think of our car as kind of like a laptop on wheels. And so software is incredibly important. And so not just in the car, but also in the factory. So the factory software is extremely important. Just software in general. These are fundamental. These are the 3 critical areas that are needed to make for an awesome company. So, yeah. So we have now we'll soon have 3 new factories, incremental, on. Well, we have one already on 3 different continents. Shanghai. We're expanding to Shanghai with the second phase. Berlin is making rapid progress, and Texas is making even faster progress. So, yeah. With each factory, what we're trying to do is also improve the manufacturing technology. So, it's in some cases, like the Model Y made in Berlin might look the same, but it actually is made in a much more efficient way. And yeah, we'll talk about that later in the battery presentation. Yeah, launched Megapack. It's a 3 megawatt hours all-in-one energy storage solution. So it's been great overall. Yeah. All right. And I think that's basically it. All right. Thank you. All right. Well, thanks everyone for coming, and we'll be back in a little bit to go through the battery stuff. And there's a little bit more in addition to the battery stuff. We got a few extras as well. So I think you'll really like what we have to say on batteries.
Oh.
The battery stuff we're going to talk about is truly revolutionary and essential to Tesla's goal. The fundamental good of Tesla. It's like if you look back in history and say what good did Tesla do? The good will be to by how many years did we accelerate sustainable energy? That's like the true metric of success. It matters if sustainable energy happens faster or slower, and so that's really like how I think about Tesla and how we should sort of assess our progress. by how many years did we accelerate sustainable energy? But what we're going to talk about with batteries and a few other things will really explain how we're going to make a step change improvement in the acceleration of sustainable energy. Thank you.
So, also jetzt geht es schon mit dem Batteriekram los, hat er gerade gesagt. Und das überrascht mich, also sehr schnell. Ja.
So stay tuned. If you're local and here in the audience today, you can feel free to get out of the cars and stretch your legs, but try to stay near the cars because we're going to begin promptly in a little bit. See you soon.
So, jetzt erstmal kurze Pause. Ja, ich habe hier parallel den Aktienkurs ein bisschen verfolgt. Also die Börse ist ja offiziell geschlossen, aber die Nachbörse geht ja immer weiter. Ist jetzt nachbörslich 1,6% hochgegangen. Also noch nicht so sensationell, aber die großen Sensationen kommen ja auch wahrscheinlich erst noch. Ja, also ich bin mal gespannt, was da jetzt kommt. Er hat ja gesagt, das ist sehr revolutionär, was jetzt kommt, und das wissen ja auch einige von uns. Also wir haben ja diese Bilder schon gesehen von dieser kleinen Keksdose. Also der Formfaktor hat sich deutlich vergrößert von den Zellen. Wahrscheinlich, wenn es halt dann auch tatsächlich die echten Zellen sind von Tesla. Und ja, ich bin mal sehr gespannt. Also es wird sehr viel auch um Produktion gehen, also auch um die Produktionsgeschwindigkeit, um die Kosten hauptsächlich, also was die Zellen dann in Zukunft auch kosten werden. Er hat ja vorher schon getwittert, dass die ganze Sache erst ab 2022 so wirklich in Volume Production geht, also in wirklich große Mengen dann geht, und sie trotzdem weiterhin so viele Zellen, wie sie auch nur kriegen können, von Panasonic, von Cuttle, von Samsung und so weiter, kriegen wollen, weil sie halt einfach viel mehr Fahrzeuge noch bauen müssen, um die Nachfrage irgendwie zu decken. Und dafür brauchen die einfach alle Zellen, die sie haben können. Und das finde ich halt schon spannend, und ich bin jetzt echt mega gespannt, was da kommt. Was er nochmal zum Autopilot gesagt hat, finde ich auch interessant. Also er hat gesagt, im nächsten Monat werden da schon die ersten Releases für diese Early Adopter, glaube ich, freigegeben von dieser neuen 4D-Variante. Also das ist halt nicht so wie früher, dass quasi jede Kamera die Bilder einzeln erkannt und gelabelt hat, also die Sachen, die da drauf waren, irgendwie erkannt hat und gesagt hat, okay, das ist ein Auto, das ist ein Fahrrad, das ist ein Fußgänger und so weiter, sondern das funktioniert jetzt quasi in 3D und auch nicht einzelne Bilder, oder einzelne Aufnahmen sozusagen, sondern halt in so einem zeitlichen Stream. Deshalb 4D. Also man hat nicht nur die 3 Raumdimensionen, sondern eben auch die zeitliche Dimension. Und er hat es in seinem eigenen Tesla schon drin und sieht halt, wie gut es funktioniert, und hat gesagt, das ist halt eine unglaublicher Schritt vorwärts für dieses ganze autonome Fahren und einfach auch die Effizienz von diesem Labeling, also wie schnell und wie gut halt die einzelnen Objekte erkannt werden. Und ja, das kam irgendwie mehr so nebenbei, aber also dieses Autonomie-Thema ist für Tesla sicherlich in der Zukunft auch ein ganz großes. Da bin ich total sicher, dass das auch die gesamte Autoindustrie nochmal neu umkrempeln wird. Also als es jetzt schon getan hat mit der Elektromobilität, das wird nochmal, glaube ich, ein deutlich größerer Hammer für alle die das eben nicht können. Wie gesagt, also ich bin ganz sicher, ziemlich sicher, dass Tesla da einen guten Ansatz gewählt hat. Ich will nicht sagen, dass sie definitiv die ersten und einzigen sind, die das jemals können werden. Aber mir gefällt einfach der Ansatz, und ich glaube, sie haben da die richtigen Wege eingeschlagen. Und ich bin jetzt super gespannt, wenn dann die ersten normalen Tesla-Fahrer dann diese neue 4D-Autopilot-Sache testen können, und dann kommen da sicherlich aus Amerika als erstes irgendwelche Videos drüber. Da bin ich super gespannt drauf. Die Zahlen von den Besuchern gehen jetzt gerade ein bisschen hoch. Also wir hatten jetzt die ganze Zeit eigentlich 30, jetzt sind wir bei 60. Das freut mich sehr, dass da ein paar zuschauen. Wie gesagt, wir werden nachher einfach den Stream gemeinsam gucken. Ich will da auch nicht immer so viel reinquatschen, weil man ja auch das hören will, was halt Elon oder die anderen auch sagen. Und genau, ich bin jetzt super gespannt, was dann nachher kommt. Vielleicht wird ja diese neue Zelle schon irgendwo eingebaut demnächst, halt in einer kleineren Menge, vielleicht dann nur für irgendwelche Plaid Model S und Plaid Model X. Das könnte ich mir zum Beispiel vorstellen. Da braucht man halt nicht so mega viele Zellen für, wie jetzt zum Beispiel fürs Model 3 oder Model Y, wo wirklich große Mengen rausgehen. Und damit könnte man halt diese Fahrzeuge noch ein bisschen einfach höher positionieren, also in der Funktion, dass sie deutlich überlegen sind den Model 3s. Aber wir werden es gleich sehen. Ich will jetzt auch nicht wieder zu viel spekulieren. Das haben wir in den letzten Monaten oder Wochen, Monaten reichlich getan. Und ja, ich bin jetzt mega gespannt. Ich gucke mal, dass wir nachher auch noch andere hinzufügen. Ich muss jetzt gerade mal kurz gucken. Ich habe nämlich auch ein paar Gäste mit eingeladen. Mal gucken, ob wir das jetzt in der Pause hier hinkriegen. Ja, also eigentlich sollte jetzt der David hier dazu kommen, aber irgendwie kriegen wir es gerade noch nicht hin. Ja, jetzt.
Kannst du mich hören?
Ja, du bist jetzt wieder extrem hallig. Mach mal das, was du vorher getan hattest, dann wird es wieder besser. Ich weiß nicht. Wir können jetzt auch mal umschalten. Also auf dem Stream sieht man jetzt gerade nichts. Wenn dann nachher wieder Ton kommt, können wir das ja mal umschalten. Ich sehe dich allerdings noch nicht. Ja, jetzt haben wir hier gerade noch ein paar technische Probleme. Das ist halt live, das ist immer nicht so einfach.
Ton besser?
Ja, jetzt ist der Ton besser und jetzt ist auch das Bild da. Jetzt schalte ich gerade nochmal um. Hallo David. Wir haben ja vorher schon mal ein bisschen geschnackt und auch ein Pre-Cap-Video gemacht. Und ja, wie aufgeregt bist du denn jetzt gerade? Und oder
Jetzt
bist du
höre
noch
ich
ganz
dich leider
ruhig?
gar nicht mehr. Ich weiß nicht, ob du mich hören kannst. Warte mal.
Ja,
Moment.
so, kannst du mich jetzt hören? Ja, wir müssen mehr Livestreams machen und es einfach üben. Dann klappt es beim nächsten Mal auch. Ja, aber vorher hast du mich doch gehört. Also
das
eigentlich.
Mikro scheint schon mal zu gehen.
Ja, also das
Jetzt.
Mikro geht, ja.
Ja, jetzt höre ich dich auch wieder.
Jetzt hörst du mich. Ah, super. Ja, also alles geklappt. Also erzähl mal, wie aufgeregt bist du denn jetzt? Jetzt geht es ja gleich los.
Ja, schon ziemlich, muss ich sagen. Moment, ich glaube, das kann weg. Ja, fand ich schon interessant, was er auch gesagt hat, wie er es zusammengefasst hat. Klar war da jetzt nicht rasend viel Neues dabei, aber ich glaube, das kommt jetzt alles.
Ja.
Und er hatte auch nochmal extra angehypt und gesagt, hey, wir haben nicht nur den Battery Day, sondern noch die ein oder andere Überraschung, die euch gefallen wird. Und
ja, genau.
Ja, da bin ich schon sehr gespannt.
Ja, das ist mir auch aufgefallen. Also, dass er dieses One More Thing schon so früh extra noch ankündigt, das ist mir auch aufgefallen. Und ja, er hat auch nochmal gesagt, dass halt diese Batteriesache ziemlich revolutionär ist und für die Zukunft von Tesla sehr wichtig ist und so weiter. Hast du es mit dem Autopilot auch mitgeschnitten? Also hat er tatsächlich gesagt, nächsten Monat? Hat er das gesagt?
Er hat gesagt, das wird eine Private Beta, also das wird eine Gruppe von Auserwählten, die das testen werden. Also Early Access Programm heißt es auf Deutsch. Ne?
Ja, genau. Aber das sind dann ja schon auch, ich sage jetzt mal, irgendwelche YouTuber und so. Also da von diesen Early Access Leuten kommen ja immer mal wieder auch Videos dann öffentlich.
Ja, da kommt schon was rüber, ja.
Also da bin ich mal mega gespannt, weil laut seiner Aussage soll das ja halt wirklich eine drastische Weiterentwicklung sein. Also auch von der Performance her, von dem ganzen Autopilot-System.
Ja, ich glaube auch, das ist ein deutlicher Sprung nach oben nochmal.
Ja.
Dürfen wir gespannt sein. Also, was ich ja auch sehr schick finde, sind diese ganzen Model Ys auf dem Parkplatz, wo die ganzen Zuschauer drin sitzen. Das finde ich echt richtig klasse.
Ja, das haben sie gut gemacht. Aber ich schneide es jetzt nicht so ganz. Also das haben sie ja wegen Corona vermutlich irgendwie so gemacht, dass die Leute getrennt sind und jetzt flitzen sie da aber einfach so rum. Da komme ich jetzt irgendwie nicht so ganz hin, was das dann bringt. Aber gut, müssen die ja wissen. Oder ist es einfach nur, dass sie es halt besser hören in den Autos dann letztendlich?
Ja, ich meine, das ist sicher eine Mischung aus, hey, wir packen mal ganz viele Model Ys auf den Parkplatz. Das ist doch eine coole Art und Weise der Präsentation auch, dass jeder mal in einem Model Y sitzt und die, ja, aber naja, ich denke, es ist so ein bisschen beides.
Ja. Ja gut, wenn man sich überlegt, die da ganz hinten, die hören halt dann nichts mehr, auch wenn du vorne sonst was für Lautsprecher auspackst.
Ja.
Ja, vielleicht gar nicht so schlecht.
Und vielleicht hat es auch geholfen bei der Genehmigung für das Event, dass vielleicht hätte sie sonst nicht so viele Leute einladen können.
Ja, das ich auch. Weil ich meine, Autokinos zum Beispiel sind ja jetzt auch irgendwie total im Boomen, also auch hierzulande. Höre ich in letzter Zeit ganz viel, weil das ist halt so die einzige Möglichkeit der Zusammenkunft bei so einem Filmevent irgendwie. Guter Schuss Marketing, ja, genau. Okay, also der Frankie34 sagt, ich kann ruhig hin und wieder simultan übersetzen. Nicht alle können so gut Englisch. Ja, ich werde es versuchen. Also ich bin natürlich kein Simultandolmetscher. Und also Elon spricht ja auch relativ kontinuierlich. Deshalb ist es immer schwierig, da irgendwie eine Pause zu finden, um da was zu übersetzen. Aber ich gebe mein Bestes, davor nachher mal ein bisschen mit zu übersetzen, gerade bei den Batteriesachen. Ja, jetzt bin ich mal gespannt, wann es losgeht. Also das hat ja ungefähr vor einer Stunde hat es jetzt angefangen, das Shareholder-Meeting. Das hatte ich auch ehrlich gesagt so erwartet, dass, ich mach mal so, das ist doch auch schick.
Haben sie ziemlich schnell durchgeprügelt, muss ich sagen. Ich dachte, das geht länger.
Ja, das haben sie gut durchgepeilt. Nee, hätte ich auch gedacht. Also auch mit Q&A und die ganzen anderen Shareholder-Meetings, das ging ja Stunden. Ich denke mal, dass die jetzt auch einfach heiß sind auf den Battery Day und jetzt endlich auch mal präsentieren wollen, was sie da haben. Es wurde ja immer wieder verschoben und im Prinzip warten wir seit April, glaube ich, drauf. Das war so die erste Ankündigung. Ja, mal gespannt. So, jetzt, was passiert jetzt hier? Ja, das ist jetzt hier nur so Promotional Video ohne Ton, was Tesla da einblendet.
Ist da kein Ton drauf?
Nee. Das kam ja vorher schon. Das hatte mich vorher schon irritiert, als die vor dem Shareholder-Meeting halt diese Promotion-Videos von den Autos halt eingeblendet haben. Da war auch kein Ton drauf, also keine Musik oder sowas. Und das hat mich auch ein bisschen irritiert. Ja, also wir sind jetzt nachbörslich 2,7% hoch. Jetzt geht's weiter. Okay, also, this is real. Ja.
Hello, everyone.
Also das ist Drew Baglino, das ist der CTO von Tesla.
Thanks, Elon.
Glaube ich, oder?
Hi. I'm Drew Baglino, SVP of Powertrain and Energy Engineering at Tesla.
Yeah.
And I'm incredibly excited to talk about what we've been doing at batteries here at Tesla.
Great. So let's see, you got the clicker?
Yeah, I've got the clicker, yeah.
Okay, I'll take it first, perhaps.
Sure.
So obviously the issues we're facing are very serious, with climate change, and we're experiencing these issues on a day-to-day basis. It's incredibly important we accelerate the advent of sustainable energy. Time really matters. This presentation is about accelerating the time to sustainable energy.
Genau, also es geht jetzt darum, dass er halt die Zeit beschleunigen will, dass wir zu nachhaltiger Energie
The past 5
kommen.
years were the hottest on
Also,
record.
ja,
We have what looks like a wall for CO2 ppm.
genau. Also jetzt geht es um Klimawandel und die Erhöhung der Temperatur. Ich denke, die meisten werden das kennen. Genau.
Running this climate experiment is insane. So,
Genau. Und es ist wichtig, dass wir jetzt halt was tun dagegen.
Just to transit everyone anyway.
Ja.
Yes, we're going to run out of these fossil fuels. Let's just move to the future and not run this experiment any longer.
Genau. Und Drew sagt, also irgendwann wird das Öl sowieso leer sein und irgendwann müssen wir umschwenken und warum nicht gleich? Das ist halt. Ja.
There is a lot of good news though. A lot of people may not be aware that wind and solar comprise 75% of new electricity capacity in the U.S. this year. So this is a really major. So the grid is going sustainable very, very quickly.
Genau, also die erneuerbaren Energien also steigern sich ziemlich schnell.
So even if 100%
und wir sind auf einem guten Weg da in der Sache. Genau, also wenn wir so weitermachen, brauchen wir immer noch 25 Jahre, um voll regenerativ zu sein. Ja.
So it went from 46% of electricity in 2010 to 23% in 2020. So this is a massive improvement. So good things are happening on a lot of levels. We just need to go faster.
Genau. Wir müssen nur schneller sein. Also es ist alles gut und wir sind auf einem guten Weg, aber wir müssen es beschleunigen.
Over 1 million electric vehicles, 26 billion electric miles driven, and many gigawatt hours of stationary batteries, 17 terawatt hours of solar generated. So I think solar is sometimes underweighted at Tesla, but it is a massive part of our future. The 3 parts of a sustainable energy future are sustainable energy generation, storage, and electric vehicles.
Genau, also das Wichtigste ist halt die erneuerbare Energienerzeugung, Speicherung und halt Transport sozusagen. Also,
EVs, they need to be affordable and a lot more energy storage while building factories faster and with far less investment. So goal number 1 is a terawatt-hour scale battery production. So tera is the new giga, and a terawatt is 1,000 times more than a gigawatt. So we used to talk in terms of gigawatts. In the future, we'll be talking in terms of terawatt hours. So this is what's needed in order to transition the world to sustainability.
Yeah, and you can see we're talking about 100x growth in batteries for electric vehicles to achieve this mission.
Genau, also jetzt geht es darum, um die Menge der Zellen sozusagen. Hat man halt übersprochen, jetzt sprechen Sie über Terawatt.
Fleet of vehicles to electric.
And the average vehicle lasts 15 years, so we're talking about 150 terawatt hours, give or take, to transition the whole all vehicles of all types to electric.
Yeah, so it's a lot of batteries, basically.
Genau.
And yeah, so.
And then on the grid side, we have a similar mountain to climb, 1,600 times growth from today's grid batteries to go 100% renewable on the grid and to take all of the existing heating fossil fuel uses in homes and businesses 100% electric.
Genau, jetzt geht es noch um das Stromnetz, braucht halt auch Speicher und da braucht man eben auch 10 Terawattstunden dafür, um auch die Heizung und alles zu ersetzen.
We could see this number be even more, but let's say it's like roughly 20 to 25 terawatt hours per year, sustained for 15 to 25 years to transition the world to renewable. This is a lot.
Yeah.
So today's batteries can't scale fast enough. They're just too small. For Giga Nevada, 150 gigawatt hours per year is like what we probably expect to make out of there. But this is really pretty small in the grand scheme of things. That's only 0.15 terawatt hours.
Genau,
and it costs too much. So
we would need 135 fully built out Nevada gigafactories to achieve 20 terawatt hours a year. It's not scalable enough of a solution.
Okay,
We
also
need a
Sie
dramatic
bräuchten
rethink
135
cell manufacturing system
Gigafactories, um
to
diese
scale
20
as fast as we can
Terawattstunden
and should.
herzustellen an Zellen.
I think we should
Und das
view this
funktioniert so nicht.
as more than just a question of money. Money is sort of like an ethereal thing, but it's really the amount of effort. You have a certain amount of effort, in terms of people and machines, and depending on how efficient that effort is, for a given amount of effort, you want the most amount of batteries. So it's not just a question of like, well, if we had $2 trillion, tomorrow you could make this. It's not that easy. You actually need to organize a massive number of people, build a lot of machines, build the machines that make the machines. And so it's incredibly important to have that effort yield the most number of batteries.
Genau, also er sagt noch, es geht nicht nur ums Geld, also mit unendlich viel Geld könnte man das auch nicht erreichen, sondern man braucht halt einfach das Engagement von den Leuten, du brauchst Personen, du brauchst Maschinen und so weiter.
We don't yet have a truly affordable car, and that is something that we will make in the future. But in order to do that, we've got to get the cost of batteries down, we've got to make, and we've got to be better at manufacturing, and we need to do something about this curve. The curve of the cost per kilowatt hour of batteries is not improving fast enough. So we've given this a lot of thought over many years to say, okay, how can we radically improve the cost per kilowatt hour?
Genau, jetzt geht es die Kosten pro Kilowattstunde. Man sieht hier, die geht erst flach, aber man muss es runterkriegen. Genau.
Exactly. So
die haben nochmal neu drüber nachgedacht, wie man Zellen macht und designt.
EV market share is growing, but EVs, still aren't accessible to all. It's and you can see, as Drew was saying, it's like starting to flatten out a little bit because the rate of improvement of the affordability of cars is just not fast enough. So that's why we got Battery Day.
Yeah, to make the best cars in the world, we design vehicles and factories from the ground up. Next.
Yeah.
And now we do this for batteries as well.
Yeah. It's weird, the slides don't show up. Right. What shows up on the screen is not quite what shows up there.
So, also jetzt haben Sie gerade gesagt, dass Sie jetzt nicht nur die Factories für Fahrzeuge von Grund auf neu erfinden, sondern eben auch auch für Zellen, die Factories. So, jetzt geht's los.
The cost per kilowatt hour.
Yeah.
Boah. Also Sie haben den Plan, um die Kosten pro Kilowattstunde zu halbieren. Also nicht 100, sondern $50 pro Kilowattstunde.
It's a plan that has taken creative engineering and industrialization across every facet of what makes a cell into a battery pack, from raw material to the finished thing. And we're going to go through that plan with you today, step by step.
Also Sie haben einen Plan von Anfang von der Zelle bis zum fertigen Pack und haben alles angeguckt, um das halt neu zu entwickeln und halt so günstig zu machen. Genau.
Almost every element. There are a few more elements that we won't get to today, but we will get to in the future.
Yes.
Genau, also Sie haben eigentlich alles angeguckt, jedes Bauteil an der Zelle. Einige wenige noch nicht, aber das werden Sie in der Zukunft machen. Genau, also es ist so eine Zelle. Ja.
We've got a tab connected to those terminals, what we call the jelly roll, which is the wound electrodes on the inside. You can actually see what this looks like as you unwind it. This is over a meter long in a typical 2170 cell.
Genau, also es ist jetzt so eine Zelle, die ausgerollt wird. Und da oben sieht man jetzt dieses Tab, also diese kleine Lötfahne, kann man es auch nennen. Und die erklären jetzt, was es ist.
Cathode separator, positive and negative terminal. Watch what happens as we, there we go, discharge the cell. Got lithium moving from anode to cathode.
Genau, wenn man die Zelle entlädt, dann gehen die Elektronen, diese gelben Punkte, halt zur Kathode und umgekehrt. Ja, so funktioniert es. Genau, also das Grundprinzip von jeder Zelle eigentlich. Egal.
The 18650 form factor to the 2170 form factor through great collaboration with our partners Panasonic, new partners like LG and CATL, and probably others in the future.
Actually, so a slight note on why is the one called the 18650, although not on the slide, versus the 2170, is that the first two digits refer to the diameter, and the second two digits refer to the length. So that helps explain why are these weird. What's up with these weird numbers? But like nobody could explain to me why there was an extra zero. So like, okay, well, we're deleting the zero that nobody can explain in future form factors. So that's why it's technically it's like the 18650 bizarrely, but going forward it's the 2170 because we just got rid of the extra zero because it's pointless.
Genau, jetzt erklärt er den Formfaktor. Das bei 18650er Zellen ist eine 0 zu viel eigentlich. Deshalb haben sie auf 2170, also 21 Durchmesser, 70 Höhe, Millimeter.
Cell design, if we were to do it ourselves, we need to go beyond just what we're looking at us in front of us and study the full spectrum of options. So as you can see, we kind of swept the key figures of merit, how much we can reduce the cost and how much vehicle range increases as we change the outer diameter of the cell.
Genau, also jetzt geht es darum, den perfekten Durchmesser und die perfekte Höhe für die Zelle zu finden.
But it's not just about a bigger form factor. Like anybody can make a bigger form factor.
Any fool can make a bigger form factor.
Ja, also
yeah, exactly.
Jeder kann die Zelle einfach größer machen, aber es bringt halt Probleme.
Supercharging and thermals in general become really challenging as you make bigger cells. And this was the challenge that our team set our sights on to overcome.
Also da kriegt man thermische Probleme. Wenn die Zelle größer wird, kann man die nicht so gut kühlen und dann funktioniert es deshalb nicht. Deshalb ist es nicht so einfach, die Zelle einfach größer zu machen.
From the equation and allows us to go to the absolute lowest cost form factor and the simplest manufacturing process. And this is what we mean when we talk about tablets. It's kind of a beautiful thing.
That's what these T-shirts mean, but it's very esoteric. Like nobody could figure it out. But
yeah, we basically took the existing foils, laser patterned them, and enabled dozens of connections into the active material through this shingled spiral you can see.
Genau, also jetzt haben sie nicht mehr diese eine Lötfahne oder diese Tab, sondern überall an der Zelle rundherum haben sie halt diese Tabs und deshalb wird die Hitze auch besser abgenommen aus dem Akku. Genau, und die Elektronen müssen nicht so einen weiten Weg fließen.
In a large tabless cell than you have in the smaller cell with tabs. This is a big deal. So even though the cell is bigger, it actually has more power. The power to weight ratio is actually better than the smaller cell with tabs. This is, again, like this is quite hard to do. So it's, nobody's done it before. And it really took a tremendous amount of effort within Tesla engineering to figure out how do we make a freaking tabless cell and have it actually work and then connect that to the top cap. And it's there's a whole bunch of things that we're keeping a little secret sauce here that we're not telling everything. But
sometimes what's elegant and simple is still hard, and it took us a lot of trials, but we're happy where we ended up.
Genau, also er will nochmal sagen, dass es nicht einfach ist, halt dieses Tabless-Design herzustellen. Genau, und es ist so lange schwierig, bis man es kann, und dann ist es einfach. Und das haben die halt geschafft und haben viele Vorteile dadurch.
It's really, due to a really great engineering team, Drew and the rest of the team have done amazing work in achieving this tabless construction. And it sounds, I think it may sort of sound a bit silly to some people, but this is like, if for people that really know cells, this is a massive breakthrough.
For cylindricals to be able to get rid of the tabs dramatically simplifies winding and coating.
Yeah.
And has an awesome thermal and performance benefit.
Genau, also durch dieses Tabless-Design ist es viel leichter, die zu wickeln. Und man hat halt thermisch einfach viel bessere Sachen. So, da sieht man jetzt also 46 Millimeter Durchmesser und 80 Millimeter Höhe.
And really slows down the rate of production. And then sometimes you get the tabs wrong, and you also lose a little bit of active area. It's really a huge pain in the ass to have tabs from a production standpoint.
Yes.
Okay.
And so when we put it all together and go to our new 80 millimeter length, 4680, we call this new cell design. We
Okay.
get 5 times the energy.
6480, das muss man sich jetzt merken. Also so heißt die neue Zelle. 4680. Ja.
Yeah. So when these, yeah, it's pretty great.
Yeah.
And just to clarify that when we see these plus 16% or whatever the percentage range increases, these are the amounts due just to that particular innovation.
Yes.
So we'll list a whole bunch of innovations, and then when you add them up, you get a total improvement in.
Also die Verbesserung, die ihr da jetzt rechts seht, zählt nur für diese Tabless Design, also nur für diese eine Innovation, die Sie jetzt gerade gesagt haben. Und am Schluss addieren Sie alles auf und dann kommt halt wahrscheinlich eine lächerlich hohe Zahl raus.
Pilot 10 gigawatt-hour production facility just around the corner.
Yeah. So. Yeah. It's a video of some of what's going on in the plant.
Wow. Genau, also das ist jetzt die Facility in Arcata Road.
It will take about a year to reach the 10 gigawatt-hour capacity. So this is important to appreciate. Like when you build a factory, there's a certain capacity that you design to, and then it takes some period of time to actually achieve that capacity.
Hat er gerade 10 Gigawatt gesagt? 10 Gigawattstunden machen die da in dieser kleinen Hütte? Wahnsinn. Ist nur eine Pilotanlage. Wow. Und die echten Anlagen sollen dann 200 Gigawattstunden produzieren. Also pro Jahr. Wahnsinn. Wahnsinn. Nochmal, Giga Nevada macht gerade, ich glaube, 34 Gigawattstunden.
Enables a 14% dollar per kilowatt hour reduction.
Wow.
Just that cell form factor change. And now that you've been teased on this factory, we're going to go on and walk step by step through that factory and discuss a series of innovations there.
Boah.
When thinking about the ideal cell factory, we have inspirations behind us in the paper and bottling industry, where from humble beginnings, over a century of innovation has enabled mass scale, continuous motion, unbelievably low manufacturing cost. And when we think about the lithium ion industry, which is really only in its 3rd decade of high volume production, it has so far to go to achieve similar scale and simplicity. And that was the inspiration that we set out to the team as we thought about how to marry Cell Design and Manufacturing in the best possible factory.
Genau, also die haben jetzt sich quasi das Printing-Business, also Druckereien und Glasherstellung oder Flaschenherstellung angeguckt, um das zu übertragen auf ihre Zellfertigung.
Then those coated foils are wound in the winding process we just talked about.
Genau, also erst kriegt man so eine Folie mit der Elektrode drauf, dann wird es aufgerollt, kommt dann in diesen Topf rein. Genau. Und dann wird es zusammengebaut und das erste Mal geladen. Genau, und dann überprüfen wir das nochmal, ob die Zelle gut ist.
To try to take that inspiration we just showed and think about how we make those processes fundamentally better and more scalable. And one of the most important processes is where it all begins, the wet process of the electrode coating.
Ja, genau. Jetzt kommt diese DBE-Technologie von Maxwell, also Dry Battery Electrode, Trockenelektrode.
The powders are mixed with either a water or a solvent.
Genau, sowas früher. Da haben sie das Pulver mit einem Lösungsmittel gemischt.
That mix then goes into a large coat and dry oven, where
kommt das durch einen großen Ofen, um das drauf zu bringen und dann wieder zu verdampfen, sozusagen, das Lösungsmittel.
And that solvent then has to be recovered. You can see the solvent recovery system. And then finally, the coated foil is compressed to the final density. And when you're looking at this,
genau, und dann muss man das wieder pressen.
That's a lot of equipment for one step, especially when you consider that little speck next to the coating oven is a person. This is serious, serious iron involved in making.
Das Kleine da ist halt ein Mensch und die Anlage ist einfach riesig.
Which
genau.
is one of those dig a ditch and then fill it kind of things where you put the solvent in and then take it out and recycle it, and just go straight to dry mix to coat. And that's what the dry process really is about. And
genau. Also Sie haben jetzt einen Trockenprozess ohne diese Lösungsmittel. Das war schon länger bekannt, also diese Maxwell-Technologie. Und da wird Puder, also Pulver aufgetragen.
Just to be clear, so you know, if this was easy, everyone would do it. So it's not like dry coating electrode is actually easy. It's actually very hard to do what appears to be a simple thing.
Genau. Also er sagt nochmal, das ist nicht so einfach, wie es jetzt hier aussieht, sondern das ist einfach einfach unglaublich schwer, das hinzukriegen, dass es dann auch funktioniert hinterher.
The dry coating they had was like sort of I would call proof of concept. Since the acquisition, we've actually revved the machine that does dry coating 4 times. So we're in revision 4 post acquisition of the machine, and there's still a lot of work to do. So I would not say this is like completely in the bag. It's still a lot of work to do, and you know, as you go from like benchtop to lab to pilot to volume production, there are actually major issues that you encounter at every level. It's not like, you know, you make something work on your bench and bingo, now you can make a bazillion of it.
Absolutely.
It's insanely difficult
Genau.
to scale up.
Also die haben auch noch viele Herausforderungen vor sich. Und je mehr sie halt hochskalieren, desto schwieriger wird es halt.
You can see the motivation.
So.
A 10 times reduction in footprint, a 10 times reduction in energy, and a massive reduction in investment.
Genau, also da geht es jetzt darum, Fabrikfläche ist 10-mal kleiner, die man dafür benötigt, und man braucht 10-mal weniger Energie für diesen Prozess. Also
close to working, but it's not even now at the pilot plant level. It is close to working. Well, it's fair to say it does work, but with not a high yield.
Yeah.
So
we're still ironing out the kinks, but we've made tens of thousands of cells, thousands of kilometers of electrode. I mean, we are on the 4th generation of the equipment, so we've learned a lot along the way. Yeah. I mean, it is super demanding because every atom has its place if you want to deliver the energy density and the cycle life and the supercharging.
Yeah.
But we're confident that we will get there, but it will be a lot of work along the way.
There's a clear path to success, but a ton of work between here and there.
Yeah.
Okay.
So,
also Sie haben es
really profound
fast am Laufen, wenn ich es jetzt richtig verstanden habe. Und
probably be on machine revision 6 or 7 by the time we do large scale production.
Genau, also sind jetzt gerade bei der 4. Generation von Maschinen für dieses Dry Coating. Und ja, haben aber noch einfach Herausforderungen vor sich. Ja.
So let's talk a little bit about assembly, which is next.
Genau, jetzt geht's zum nächsten, also zum Zusammenbau von dieser Geschichte.
A high-performing assembly line is accomplishing processes while in motion, continuous motion, and thinking of the line as a highway. Max velocity down the highway, no start and stop, no city driving.
Exactly, no stoplights and traffic lights or anything. You want the highway.
I want the highway.
Yeah.
Genau, also hier geht es jetzt einfach darum, in dem Zusammenbau, dass alles immer in Bewegung ist. Also dass sie nicht, wir haben es jetzt mit einer Autobahn verglichen, dass es nicht irgendwie Stadtverkehr ist mit Stop and Go, sondern wirklich permanent einfach läuft. Also das sieht man hier ganz gut. Genau.
Implement assembly lines. One line, 20 gigawatt hours.
Okay. Wow. Okay, also auf einer Produktionslinie wollen Sie jetzt 20 Gigawattstunden herstellen. Das ist 7-mal so viel wie bei den aktuellen Anlagen, die halt in Nevada laufen. Mega.
You can sort of think about like the sort of the fundamental physics of a factory or something like. I think it's actually quite a lot like
7-mal so viel, ey, das muss man sich mal denken, ey. Wahnsinn.
Basically, in the rock equation, you've got your exhaust velocity and then the log of the start end masses. So it's basically saying, you know, how fast are things going and what percentage of the factory volume is doing useful work. And conveyance does not count as useful work. So
only the value-added steps.
Yeah, if you break the factory down into cubic meter sections and say. Or smaller, it could be like 1 liter sections, and say, is a majority of this volume doing useful work? You would be astounded at how bad most factories are. They're like maybe 2 or 3%.
Also redet jetzt drüber, dass man eine Fabrik danach messen sollte, wie viel oder welche Fläche wirklich dafür genutzt wird, das Produkt herzustellen. Und er sagt, man wird es nicht glauben, wie viel Fläche in so einer Fabrik ungenutzt ist. Ja. Genau.
And then the other thing is, how fast are things going through the factory? It's like speed and density.
Und wenn man das wirklich optimiert, können sie 10-mal kleiner sein.
Like a factory that's moving at say twice the speed of another factory is equivalent to two factories, basically.
Genau. Und wenn man dann noch die Geschwindigkeit erhöht von dem Output, dann kann man mit der doppelten Geschwindigkeit quasi genauso viel Produkte machen wie mit 2 Fabriken. So, das ist ja mega.
With one factory achieve what maybe 5 or even 10 factories would normally be required to achieve.
And the vertical integration with the machine design teams at Groman and Highbar and others allows us to really accomplish that, because we don't have all these edge conditions between one piece of equipment and another. We can design the entire machine to be one machine and remove all of these unnecessary steps.
Genau, und sie machen die Maschine so wie aus einem Stück, also nicht 5 Maschinen hintereinander, wo man dann irgendwelche Sachen übertragen muss, sondern einfach eine Maschine am Stück. Und das ist halt super.
Basically, achieving sustainability as fast as possible. But I think also for long-term competitiveness, eventually every car company will have long-range electric cars. Eventually every company will have autonomy. I think, but not every company will be great at manufacturing. Tesla will be absolutely head and shoulders above anyone else in manufacturing.
Jetzt sagt er gerade, dass viele Unternehmen wahrscheinlich Elektroautos haben werden und auch autonom fahrende Fahrzeuge, aber die meisten werden nicht gut sein, die Sachen herzustellen. Also das ist ja bei Tesla auch ein großes Thema, einfach die Fabrik als Produkt. So,
formation represents 25% of the investment. And what is formation? It's charging and discharging cells and verifying the quality of the cell. Turns out we've charged and discharged billions and billions of cells in our vehicles, so we know a thing or two about that. The typical formation setup is you charge and discharge each cell individually. In our car, we charge thousands of cells at once. And we took our principle and our power electronics, leveraging Powerwall, vehicle battery management systems, and others to dramatically improve the formation equipment cost effectiveness and density. 86% reduction in formation investment, 75% reduction in footprint.
Okay, also da geht es jetzt um den Zusammenbau insgesamt, und das haben sie auch, also ihr habt gerade die Prozentzahlen gesehen, also um wahnsinnige Beträge reduzieren können. Also nicht nur in der Effizienz, sondern auch im Raumvolumen. Genau. Genau, also jetzt geht es um Investitionen. Ja, also es ist 4-mal besser, oder die kriegen 4-mal mehr Gigawattstunden pro Investitionseinheit als früher. Yeah,
we're able to, from a volume standpoint, actually get what in a smaller form factor than Giga Nevada, we were able to get many times the cell output. So
genau, also wenn man eine Fabrik baut, die kleiner ist als die Giga in Nevada, kriegt man trotzdem mehr Output raus mit dieser halt neuen Technologie, weil man einfach weniger Platz braucht, die ganze Sache schneller abläuft und ja.
That we could actually get to terawatt-hour scale in less space than what we currently envision for doing 150 gigawatt-hours.
Yes, simpler accelerates terawatt-hour scale, and that's what we need to do to accelerate our mission.
Also jetzt sagen sie wieder, dass sie auf den Terawattstunden Scale gehen, also in gleichem oder kleinerem Footprint wie die Gigafactory in Nevada, da wirklich Terawattstunden rauszuhauen.
This is just talking about Tesla internal cell production. As I tweeted out earlier, we will continue to use our cell suppliers, the Panasonic and LG and CATL.
Genau, also er sagt nochmal, dass wir weiterhin auch Zellen kaufen von Panasonic, LG und CATL. Aber diese 3 Terawattstunden in 2030, das ist nur quasi die eigene Produktion. Ja. Genau, sie brauchen einfach jede Zelle, die sie kriegen können für die Fahrzeuge, die sie verkaufen wollen. Das ist ganz klar.
3,000 gigawatt-hours or 3 terawatt-hours per year. I think we've got a good chance of achieving this actually before 2030, but I'm highly confident that we could do it by 2030.
Genau, also sie können es vielleicht schon vorher erreichen, diese 3 Terawattstunden, also vor 2030, aber er ist sehr sicher, dass es 2030
And not
da
only
sein wird.
is all
Genau.
of that manufacturing innovation fantastic for enabling scale, it's also an additional 18% reduction in dollar per kilowatt hour at the battery pack level.
But wait, there's more.
But wait, there's more.
But wait, there's more. Genau, jetzt kommt noch mehr. Geht ja noch weiter. Sind nur noch
So we have a
zwei Schritte
manufacturing
da.
system. We've got a cell design. What are the active materials we're going to put in that cell design? Let's talk about the anode first. Let's talk about silicon. Why is silicon
Wow,
awesome?
jetzt kommt
It's awesome because
Silizium
it's the most
für die
abundant
Anode.
element in the Earth's crust after oxygen, which means it's everywhere. It's sand.
Yeah.
Um,
Sand is silicon dioxide.
yeah. And it happens to store 9 times more lithium than graphite, which is the typical anode material in lithium-ion batteries today. So why isn't everybody using it? The main reason is because the challenge with silicon is that it expands 4x.
Genau, das haben wir im Precap-Video schon gesagt, dass das an Silizium das Problem ist, dass es sich sehr stark ausdehnt, wenn es geladen wird.
Isolating, you lose capacity, the energy retention of the battery starts to fade, and it also gums up with a passivation layer that has to keep reforming as the particles expand.
Yeah, basically with silicon, the cookie crumbles and gets gooey. That's basically what happens.
Good analogy.
Yeah.
Okay.
And current approaches to solve this, which exist,
Also
we have
die-
silicon
ja.
in the cars that you're all in right now, are involved highly engineered, expensive materials in the scheme of things. Now, they're still great, and they enable some of the benefits of silicon. They just don't enable all of it, and they're not scalable enough. And you can see
Okay.
some of the things that maybe you've heard of, SiO, silicon with carbon, or
Genau,
silicon
das sind jetzt
nanowires.
Verbindungen
That's kind of the space right now.
aus
What we're
Silizium.
is
Und jetzt
a
kommt, was
step
Tesla
change
macht.
in capability and a step change in cost. And what that really is
Und das ist
just
halt
good
teuer
raw
gewesen und
metallurgical
jetzt,
silicon itself. Don't
Genau.
engineer the base metal. Just start with that and design for it to expand in how you think of the particle in the electrode design and how you code it.
Yeah, I'm not sure if you saw this. Basically, $1.
okay, also jetzt ist wieder dieses First Principle Geschichte, dass es sehr günstig ist, wenn man nur Silizium nimmt. Das ist sehr, sehr günstig. Und alle anderen Lösungen sind halt sehr teuer. Ihr seht es hier rechts, $1,2 pro Kilowattstunde, die Anode. Und ja, das ist sehr, sehr wenig. Also wenn man heute von $100 pro Kilowattstunde ausgeht für die gesamte Zelle, dann oder auf Pack-Level, also fürs Pack halt. Genau. Und jetzt kriegen die quasi eine Beschichtung, also die einzelnen Siliziumbröckel und dann genau, wird es halt zusammengepresst auf der Anode. Und nur das bringt halt weitere 20% Reichweite. Und es ist deutlich günstiger, das habt ihr gerade gesehen, als halt die aktuellen Lösungen.
Yeah, and when we take that anode cost reduction, we're looking at another 5% dollar per kilowatt hour reduction at the battery pack level.
Okay.
And there's more.
So, und jetzt kommt noch
Let's
was.
talk about cathodes. What is a battery cathode?
Genau, jetzt kommt die
Cathodes are like
Kathode.
bookshelves, where the metal, the nickel, the cobalt, the manganese, or aluminum is like the shelf, and the lithium is the book. And really, what sets apart these different
Genau, und die sind halt aus Nickel und Lithium oder Kobalt und Lithium und so weiter.
Yeah, sorry, I was just gonna say, like, it's tough to exactly figure out what the right analogy is to explain cathode and anode, but a bookshelf is probably a pretty good one, in the sense that
genau, also ich vergleiche es jetzt mit dem Buchdeckel, die ganze Sache.
Crumble or get gooey or basically that holds its shape.
Das hält die ganze Sache zusammen und verhindert, dass es, was innen drin ist, kaputt geht. Wie halt so ein Buchdeckel.
If it doesn't retain its structure, then you lose cycle life and your battery capacity drops very quickly.
Genau.
Absolutely.
Also die Kathode sorgt halt dafür, dass das alles so bleibt, wie es ist und alles stabil bleibt.
Like, oh, what's the cathode going to be? Is it NCA or whatever, The thing to consider is just fundamentally what the nickel, the metals are capable of. And that's what we have on the chart here. Dollar per kilowatt hour cathode of just the metal using just LME, London Metal Exchange prices, versus the energy density of just the cathode. And you can see nickel is the cheapest and the highest energy density. And that's why increasing nickel is a goal of ours and really everybody's.
Genau, also sie wollen viel Nickel in die Kathode tun, weil das halt eine hohe Energiedichte hat und sehr günstig ist. Genau. Genau, und der Grund aber Kobalt zu nehmen ist, dass es halt stabiler ist und deshalb macht man das halt. Genau. Genau, und jetzt haben sie eine Nickel-Kathode entwickelt, also eine High-Nickel, sag mal, mit viel Nickel und ohne Kobalt. Und genau, wir haben jetzt hier also für die Kathode $5 pro Kilowatthour. Genau, und jetzt.
Yeah, sure. So in order to scale, we really need to make sure that we're not constrained by total nickel availability.
Genau. Und jetzt gibt es auch noch andere Kathodenmaterialien, um ja einfach besser zu diversifizieren für verschiedene Anwendungsfälle auch. Um nicht so abhängig vom Nickel auch zu sein.
We need to have
Ja.
a kind of a three-tiered approach to batteries. So starting with iron, that's kind of like a medium range, and then nickel manganese as sort of a medium plus, intermediate, and then high nickel for long range applications.
Genau, also es gibt die drei Kathodenmaterialien. Das ist einmal Eisen, das ist halt günstig, wahrscheinlich für Hausspeicher und für die kleinen Reichweiten, also Standard Range Model 3. Dann Nickel, Mangan und halt die High Nickel für die High Performance Autos.
If you look at the watt-hours per kilogram at the cathode level of iron, it looks like nickel's twice as good. But when you fully considered at the pack level, everything else taken into account, nickel is about maybe 50 or 60% better than iron. So,
okay, also die Eisenkathode ist dann auf dem Pack-Level ungefähr 50% schlechter als die Nickel-Sache, beziehungsweise Nickel ist 50% besser. Deshalb für die High-Performance-Sachen halt eine Nickel-Kathode und
medium-range applications where energy density is not paramount. And then, like I said, for intermediate, it's kind of nickel manganese, and it's relatively straightforward to do.
In der Mitte halt Nickel mit Mangan als Kathode.
Which would then allow us to make 50% more cell volume with the same amount of nickel.
And with very little energy trade-off. I mean, just enough to have you still want to use 100% nickel for something like a semi-truck, but really not much of a sacrifice.
Yeah.
Genau, also für einen Semi-Truck wollen sie 100% Nickel nehmen, aber für andere Fahrzeuge, wo halt nicht so viel Reichweite und Performance gebraucht wird, halt entweder Nickel, Mangan oder halt Eisen.
$1 per kilowatt hour is just in transferring it into its final form. And so we see that as a big target, and we decided to take that on. Here's a view of the traditional cathode process. Effectively,
okay, also
the left and you have the metal from the mine.
Der Prozess, die Kathode herzustellen, ist halt sehr nimmt einen sehr großen Teil der Gesamtproduktion der Zelle ein.
And then when you're making the cathode, you have to take this intermediate thing called metal sulfate, add chemicals, add a whole bunch of water. A whole bunch of stuff happens in the middle, and at the end, you get that little bit of cathode and a whole bunch of wastewater and byproducts.
Yeah, it's basically insanely complicated.
Also das ist der alte Prozess gewesen, wo sehr viel Abfall und Wasser verbraucht wird und so weiter. Also Abfall entsteht und Wasser verbraucht wird. Und es ist irgendwie total verrückt, sagt der Elon jetzt gerade. Dieser Prozess wirklich verrückt ist. Ja.
They're just kind of like legacy things that it's like how it was done before, and then they connected the dots, but really didn't think of the whole thing from like a first principle standpoint, saying how do we get from the nickel ore in the ground to the finished nickel product for a battery.
Genau, und Tesla hat jetzt halt den ganzen Prozess nochmal durchgedacht, also wirklich von dem Nickel, was aus dem Boden kommt, bis zur Kathode. Und das ist das, was jetzt übrig geblieben ist. Also genau, Metall und Wasser kommt rein. Dann haben sie halt 66% weniger Investition und 76% weniger Prozesskosten, also um das herzustellen, und kein Wasser, was irgendwie verbraucht wird auf dem Weg dorthin. Das ist ja auch immer ein Riesenthema.
Ja. It dramatically simplifies the metal refining part of the whole process. So we can eliminate billions in battery-grade nickel intermediate production. It's not needed at all.
Yeah.
We can also use that same process we showed on the previous page to directly consume the metal powder coming out of recycled electric vehicle and grid storage batteries. So this process enables both simpler mining and simpler recycling.
Also der Prozess vereinfacht das Mining, also die Rohmaterialien, die gebraucht werden, und man kann auch recycelte Materialien dafür einfacher nehmen. Genau.
For nickel and lithium. And just doing that, just localizing our cathode supply chain and production, we can reduce miles traveled by all the materials that end up in the cathode by 80%.
Okay, und dadurch, dass Sie jetzt alles, also die ganze Produktion in einem zusammenfassen, könnt ihr auch wahnsinnig viel Transport einfach sparen zwischendrin und den Prozess weiter vereinfachen.
And on that note, the way the lithium ends up in the cell is through the cathode. So then we should obviously on-site lithium conversion as well, which is what we will do using a new process that we're going to pioneer. That's a sulfate-free process again, skip the intermediate. 33% reduction in lithium cost, 100% electric facility co-located with the cathode plant.
Okay, also diese ganze Sache, also auch das Aufbringen von dem Lithium auf der Kathode, wird dann alles in einem unter einem Dach quasi gemacht.
Lithium is not like oil. There's a massive amount of it pretty much everywhere. In fact, there's enough lithium in the United States to convert the entire United States fleet to electric.
Okay, also er sagt jetzt, Lithium ist genug da. Also allein in den Vereinigten Staaten ist genug Lithium schon gefunden. Also ist schon genug da, um die gesamte Fahrzeugflotte in den USA halt durch Elektroautos zu ersetzen. Also Lithium ist genug da.
Extract the lithium and do so in an environmentally friendly way. And we actually discovered again, looking at a sort of first principles physics standpoint, instead of just the way it's always been done, is we found that we can actually use table salt, sodium chloride, to basically extract the lithium from the ore.
Okay, und Sie haben jetzt herausgefunden, dass man Tafelsalz benutzen kann, um das Lithium aus diesem Erz irgendwie zu extrahieren. Und das ist halt sehr umweltfreundlich und einfach zu machen. Und
over 10,000 acres.
Und Sie haben jetzt auch, ich glaube, halt so ein Lithiumabbaugebiet bekommen oder gekauft.
It will look pretty much the same as before, and it will not look like terrible, and yeah, it'll be nice.
Okay, also es ist halt umweltfreundlicher Abbau von Lithium und auch die Extraktion ist wohl gut.
Yeah,
genau, also es ist ein sehr einfacher Prozess
so we're really excited about this
und auch was ganz Neues.
Lithium in Nevada alone to electrify the entire U.S. fleet.
Yeah, I think that's true. Actually, just what's in Nevada, that's basically so much damn lithium on Earth, it's crazy. It's one of the most common elements on the planet.
And eventually, as we said at the beginning, when we get to this steady state 20 terawatt hours per year of production, we will transfer the entire non-renewable fleet of both power plants, home heating and battery and industry heating and vehicles to electric. And at that point, we have an awesome resource in those batteries to recycle.
Genau, also hier geht es jetzt um Recycling.
Do any more mining at that point, and you can see why.
Genau.
The difference in
aus den recycelten Zellen, da ist die Konzentration von den benötigten Sachen viel höher als in dem Eisenerz oder in dem Erz. Weil jetzt gerade die Vergleiche hier.
To continue to develop this process as our recycling returns grow. Yeah, I mean, to date it's been done by third parties, but we think we can recycle the batteries more effectively. Especially since our batteries, we're making the same battery as the thing we're recycling. So whereas like third-party recyclers have to consider batteries of all kinds.
Yeah.
Genau, also sie wollen auch diesen Recycle-Prozess irgendwann selber machen, weil es einfacher ist, weil die wissen, welche Zellen sie gerade zurückkriegen, dann besser sortieren können und halt auch nur eine Sorte von Zellen bekommen und nicht alle möglichen, so wie Drittanbieter für dieses Recycling.
Yeah. Long-term, new batteries will come from old batteries once the fleet reaches steady state.
Genau, also es wird halt ein kontinuierlicher und geschlossener Prozess, das Recycling und neue Batterien und ja, so wie man sich es halt wünscht. Genau.
Almost at our halve the cost goal, but there's one more section. Take it away, Elon.
So there's an architecture that we've been wanting to do at Tesla for a long time, and we finally figured it out. And I think it's the way that all electric cars in the future will ultimately be made. It's the right way to do things.
So, Sie haben jetzt nochmal die Produktion von Fahrzeugen neu überdacht und wie so ein Auto gebaut wird in Zukunft. Also genau, das ist jetzt der gesamte hintere Rahmen vom Model Y, also das wird nicht aus Blech zusammengeschweißt, sondern eben aus Aluminiumdruckguss, das sieht man jetzt hier gerade, und kostet 40% weniger und ja, sind 79 Teile weniger pro Auto, weil es halt ein großes Teil ist, statt viele kleine Blechteile, die zusammengeschweißt werden.
This is a big deal for castings, especially with a large casting. If you heat treat it afterwards, it tends to deform. It kind of like does this like potato chip thing. So it's very hard to keep a large casting.
Genau, Sie mussten halt hinkriegen, eine Legierung zu finden. Das haben Sie selber gemacht, die man hinterher nicht mehr Hitze behandeln muss, also nochmal aufheizen, damit es stabil genug wird, weil sich sonst das ganze Teil verzieht. Und genau. Genau, und das haben Sie halt selber entwickelt. Das hat er jetzt gerade gesagt. Das ist Aluminium dafür. Genau, vorne und hinten ist ein Teil.
That then interfaces to what we call it the structural battery, where the battery for the first time will have dual use.
Okay, und die Batterie, die verbindet dann diese zwei Teile, also den Rahmen vorne und hinten, und übernimmt auch strukturelle Anforderungen.
So the fuel tanks actually were quite difficult to carry. They're like basically worse than cargo. You had to kind of bolt them down. It was very difficult.
Genau. Das ist jetzt bei Flugzeugen. Früher war halt der Tank einzeln im Tank drin, im Flügel drin. Und jetzt haben sie halt die Tanks in den Flügel integriert oder in die Tragfläche. Beziehungsweise der Tank hat die Form einer Tragfläche. Und deshalb haben die halt viel... Genau.
We're doing the same for cars.
Genau, und das machen sie jetzt fürs Auto, dass die Batterie eben nicht einfach nur eine Batterie ist, die da irgendwo dran geschraubt wird, sondern dass die Batterie ein wichtiger Teil der Struktur des Fahrzeugs darstellt.
The non-cell portion of the battery has negative mass. So we save so much mass in the rest of the vehicle. We save more mass in the rest of the vehicle than the non-cell portion of the battery. So it's like, well, how do you really minimize the mass of a battery? Make it negative.
Genau, und dann
non-cell portion of the battery pack negative.
Dadurch sparen die halt wahnsinnig viel Gewicht und natürlich Teile in dem gesamten Fahrzeug. Und die können die Zellen näher zusammentun. Ja, sieht man jetzt oben halt die alte Bauweise mit den kleinen Zellen und unten seht ihr halt die großen neuen, was waren 46, 80er. Genau.
Instead of having just a filler that is a flame retardant, which is currently what is in the 3-in-Y battery packs, we have a filler that is a structural adhesive, as well as flame retardant. So it effectively glues the cells to the top and bottom sheet. And this allows you to do shear transfer between the upper and lower sheet. Just like if you have like a Formula One craft or like a racing boat, and you have carbon fiber face sheets and say aluminum honeycomb between them, this gives you incredible stiffness, and it's really the way that any super fast thing works. Is you create a basically a honeycomb sandwich with two face sheets. This is actually even better than what aircraft do, because aircraft do not do this. They can't do this because fuel is liquid. So in our case, the batteries are solid. So
und sie nutzen sogar auch die Batterien selber, also diese Töpfe, um die Struktur des Fahrzeugs darzustellen. Also um das, was über den Zellen und unter den Zellen ist, miteinander zu verbinden und die ganze Sache halt dadurch unglaublich steif und stabil zu kriegen. Ja.
That had no upper structure, it would be stiffer than that convertible would be stiffer than a regular car. So this is it's just really really major. So it improves the mass efficiency of the battery, and then those castings are also quite important because you want to transfer load into the structural battery pack in a very smooth, continuous way, so you don't put arbitrary point loads into the battery. So you have
genau, und auch die
die
Belastung wird auch sehr gut verteilt, weil halt überall also die obere Struktur und die untere Struktur halt auf ganz viele einzelne Zellen diese Last halt verteilt. Genau.
So the volumetric efficiency of the structural pack is much better than a non-structural pack, and we actually bring the cells closer to the center, and because they're closer to the center, it reduces the probability of a side impact potentially contacting the cells, because it has to go in any kind of side impact has to go further in order to reach the cells. It also improves what's called the polar moment of inertia, which is that you can think of like when there's ice skater, arms out or arms in. Arms in, you rotate faster. So if you can bring things closer to the center, you reduce the polar moment of inertia, and that means the car maneuvers better. It just feels better.
Okay, also
it just feels more agile.
Bringen auch die Masse mehr zur Mitte des Fahrzeugs, um einfach die Agilität vom Fahrzeug ein bisschen zu verbessern. Wenn halt mehr Masse innen ist, dann fährt es einfach ein bisschen stabiler. Genau.
I mean, I really think that long term, any cars that do not take this architecture will not be competitive.
And it's not just
okay. Und er denkt, alle Fahrzeuge, die das so nicht machen werden mit dieser Batterie als Hauptstruktur, werden halt nicht konkurrenzfähig sein. So, also das ist halt so eine große Verbesserung fürs Gewicht und insgesamt und auch für die Produktion, dass das Tesla hier einen riesen Vorteil hat.
Major improvements on all fronts, from the cell all the way to the vehicle.
And in addition to the improvements we just said on enabling additional range and improving the structural performance of the vehicle, it is worth another 7% per kilowatt hour reduction at the battery pack level.
Und das ist nochmal 7% wert für diese Kostenreduktion auf 56%. Wahnsinn. Also da müssten die theoretisch unter $50 pro Kilowattstunde sein. Das
so stacking it up.
Da nochmal kommen.
We're not just talking about cost or range. We've got to look at all the facets. So range increase, we're unlocking up to 54% increase in range for our vehicles and energy density for our energy products. 56% reduction in dollars per kilowatt hour at the battery pack level, and a 69% reduction in investment per gigawatt hour, which is the true enabler.
69% Investitionskosten gespart, also weniger Investitionskosten. Und das ist natürlich auch Wahnsson, wenn man jetzt gerade so am Wachsen ist, ist natürlich der Hammer. Also das ist Wahnsinn.
I mean, 0.420%, of course. So what this enables us to do is achieve a new trajectory in the reduction of cell cost. And to be clear, it will take us probably a year to 18 months to start realizing these advantages, and probably to fully realize the advantages, probably it's about 3 years.
Okay, also um diese ganzen Verbesserungen einzubringen, wird es noch ein Jahr oder 18 Monate dauern. Und bis es voll ausgerollt ist, diese neue Sache, kann es noch 3 Jahre dauern. Also das heißt, es dauert noch.
So, what tends to happen as companies get bigger is things tend to slow down. Well, actually, they're going to speed up.
Ja, genau.
And they have to speed up if we're going to accelerate the transition to sustainable energy.
Yeah. I mean, long term, we want to try to replace about, at least 1% of the total vehicle fleet on Earth, which is about 2 billion vehicles. So long term, we want to try to make about 20 million vehicles a year.
Okay. Man 20 Millionen Fahrzeuge pro Jahr
But I think it's
herstellen.
important to point out that
Ja.
when we talked about 3 terawatt hours by
Das wird wohl noch ein
2030,
bisschen
the
dauern.
problem is a 20 terawatt hour problem.
Ja.
So everybody needs to be accelerating their efforts to accomplish these objectives. Doesn't matter where you are in the value chain, there is a ton to do. You need to rethink from first principles how you do it so that you can scale to meet all of our objectives.
Genau. Und jetzt appellieren Sie halt nochmal an alle anderen, die in diesem Prozess beteiligt sind,
What does this mean?
hier auch,
What does this mean for our future products?
dass sie auch mitmachen müssen und da auch halt skalieren,
We're
um
confident
das
that
zu
long term we
unterstützen.
can design and manufacture a compelling $25,000 electric vehicle.
Okay. Also Sie wollen $25.000
this has always
Elektroauto
been our dream from the beginning of the company.
bauen.
I even wrote a blog
Das
piece about
ist
it.
Model 2 oder wie Sie es auch immer
Our
nennen.
first car was an expensive sports car, and then it was like slightly less
Und das
expensive sedan,
erreichen Sie
and
halt
then
durch
finally
diese
sort of
ganzen Verbesserungen.
I don't know, mass market premium, but like the Model 3
Und es
Model Y.
wird halt natürlich
But really, it was
trotzdem
always our
Tesla
goal to
sein,
try to
also
make
hohe
a really
Reichweite,
electric car.
wird super beschleunigen und so weiter.
I think probably, like I said, about 3 years from now, we're confident we can make a very compelling $25,000 electric vehicle.
Okay,
That's
in
also
3
fully
Jahren, hat er jetzt
And when you
gesagt.
think about the
Mit
$25,000 price point, you have to consider how much
Full Self-Driving, also mit voller
how much
Autonomie.
less expensive it is to own an electric vehicle.
Ja,
So actually, it becomes even more affordable at that $25,000 price point.
Yeah.
genau.
So we have and extreme performance and range, and we should probably talk about the Model S Plaid. What about that?
Genau, also jetzt kommt das Model S Plaid, also der neue Plaid-Antrieb. Oh. In unter 2 Sekunden 0 auf 60 Meilen.
Yeah. Woo. So, we took the latest Plaid out to Laguna Seca on Sunday. It got a minute 30, and we think probably there's another 3 seconds or more to take off that time. So we're confident the Model S Plaid will achieve the best track time of any production vehicle ever, of any kind, two-door or otherwise. And you can order it now, and it's available basically end of next year. So, and now we'll move to Q&A.
Absolutely.
So we'll invite a few people on stage.
Come on up, team.
This is just a small portion of the team, but
Jetzt habe ich das Beste vergessen.
join
Verpasst.
some more of the team, and
Sorry.
and when we do Q&A, we can give various people different questions to answer.
Sounds great. Actually, I don't know how we're getting the questions.
Actually, I don't know either. Okay, well, you could just you can maybe get out of the car for 2 seconds and yell it at us. I don't know. Hey, how do we get any questions?
Oh, they're mics. Okay, wait for the mic.
Oh, there are mics. Okay, great.
All right.
Okay, we'll definitely need to give people mics because otherwise, there's no way.
So, jetzt kommt noch die Questions and Answers, also Fragen- und Antwort-Runde.
All right, we're going to pass some mics out. We don't have a name for the $25,000 car yet.
It's a great question, though.
Yes, we will be manufacturing cells in Berlin. Yep.
Okay, also Sie machen Zellen in Berlin, also in Grünheide in der Gigafactory. Das
For homes.
Oh, you
machen
mean like
Sie.
the home HVAC? Yeah, I mean, that's a pet project I'd love to get going on. I don't know, maybe we'll start working on that next year.
Genau, es war jetzt die Frage nach
I
einer
just think this
Klimaanlage für
would really
Häuser.
make a way better home HVAC system that's
Und
really quiet and
er hat
super
jetzt gesagt, dass
efficient
es wahrscheinlich nächstes Jahr
and, super energy
angehen werden, das
efficient,
Thema,
and
aber
also has like a
ist
a way
natürlich
better filter, for particles and
ja, nicht Hauptfokus von
it just-
Tesla.
and it works very reliably.
Okay,
And
danke
we've
Markus.
already developed that for the car.
Plaid
So
in
the heat pump,
2021
in
mit
the
ja,
Model Y,
1100
is really
PS.
pretty spectacular.
Ja.
I mean, it's tiny.
Braucht
it's
kein
efficient,
Mensch.
It has to last for 15 years. It's got to work in all kinds of conditions, from the coldest winter to the hottest summer. So we've actually already done a massive amount of the work necessary for a really kick-ass home HVAC. And they could also like stack them. So if you want to say, depending upon the size of your house or whatever, how much you need, you can just basically stack them, and just have a very compelling, super efficient home HVAC. And then you can also communicate with the car, and it'll know when you're coming home. So it's like, oh, I don't need to keep the house cold all day. I'll just, cool it down because I knew you were coming home. So the pack can communicate with the car and just like really dial it into when you actually need cooling and heating. It'd be great.
Fun product.
Yeah.
Who's next?
Hello. Hey guys, Eli here from Tesla Owners Club, My Tesla Adventure. Just quick question. So I'm a huge fan of car camping in my Tesla with my dream case, like my all-time favorite activity. Is it going to be possible to get climate control to the back of the Cybertruck? Because that would be the ultimate camping machine if we can get all-night climate control.
We'll try to do that. Yeah. I agree. That would be really cool. Yeah.
Okay. Der Matthias hat jetzt gerade geschrieben, im Konfigurator ist es schon drin.
Great guy. Just a question.
Also das Plaid Model S kostet $134.000.
In the future.
Ja. Aber
well,
so viel mehr sieht man da jetzt nicht. Aber halt sehr teuer. Kleiner 2 Sekunden. 520 Meilen Range. Ja. Natürlich schon heftig, aber 2021, also nächstes Jahr wird es rauskommen, wahrscheinlich. Ryan McCaffrey, den kennen wir doch alle.
It was interesting to see where you had it in on the battery technology front. I'm sort of curious what you see for it in the production front. Is its volume, trucks are so popular in America. Do you see its volume equaling the 3 or the Y in the future? And also, were you able to get Tesla is able to legally be sold in Texas as part of the Giga Texas deal?
So, jetzt kam eine Frage aus Cybertruck, also Stückzahlen, ob die so groß sind wie Model 3 oder Model Y.
The orders are gigantic.
So, Elon sagt, die Bestellungen sind riesig, aber aber das hat ja auch nur $100 gekostet, diese Bestellung, und ja, da werden wahrscheinlich nicht viele von wirklich in Fahrzeuge umgewandelt, letztendlich.
Now we are designing the Cybertruck to meet the American spec, because if you try to design a car to meet the global, that's the superset of all global requirements, it basically, you can't make the Cybertruck. It's impossible.
Okay, also nochmal ein Hinweis, dass der Cybertruck so in Europa wahrscheinlich nicht kommen wird, weil die den Cybertruck nicht für alle Märkte gleichzeitig designen können, sondern eben nur auf die USA zugeschnitten sind, und das klappt dann halt für Europa wahrscheinlich so nicht. Ja, das ist einfach zu groß für die meisten Märkte.
I don't know, I think probably we'll be able to sell directly in Texas. We do pretty well right now, but it is a bit weird not being able to actually conclude a transaction in Texas, but it's got to be like, a click on a server based in California. So, but weirdly, we can do leasing in Texas, but not selling. But hopefully that'll get cleared up in the future.
Yeah, Elon, great job with everything that you're doing. Thross Gerber from Gerber Kawasaki. Your team's amazing. what I'm most curious about, these innovations are incredible, but on my drive up here, fully on autopilot for 400 miles, the entire state is brown. And this is ultimately about climate. Has there been some analysis done if all these things are achieved? What will its direct impact be on climate?
Well, I mean, I think it'll have a very significant impact because it will stop the CO2 ppm from growing as it is every year. And I mean, I should say, like, I try to view the whole climate thing for, as a science question as much as possible. Science, you always question your hypothesis. Is it true? Is it not true? Or assign a probability to a given hypothesis. And I should say that my original interest in electric vehicles predates the climate issue. Like, just when I was in high school, it's like, I thought, man, if we don't figure out electric cars, the whole economy is going to collapse when we run out of oil. So it's like, we better figure out electric cars and sustainable energy, or civilization is going to crumble. And then it was only kind of later that the significance of the climate risk became apparent. We were also able, using tracking and other types of technology, to access a lot more fossil fuels than previously thought, which is, helpful for lowering the cost of gasoline, but it's pretty bad for the total tonnage of CO2 that you could put in the atmosphere. It's now greatly beyond what people previously thought. So,
also es geht jetzt um den Einfluss von Teslas Elektroflotte auf den Klimawandel.
To accelerate the advent of sustainable energy. I mean, the entire global economy is still.
Ja, sieht es auch noch aus einem anderen Blickwinkel, dass wenn das Öl halt leer ist, dass auch die Wirtschaft zusammenbricht, weil halt niemand mehr Sachen transportieren kann. Und so ist er ursprünglich gedanklich an die Sache rangegangen. Und dann kam halt diese Klimawandelsache noch mit dazu. Und ja, dafür ist natürlich auch gut. Und man hat aber auch Wege gefunden, halt neues Öl zu erschließen durch Fracking und so weiter. Deshalb ist auch die Menge an CO2, die man in die Luft pusten kann, jetzt größer geworden.
To massively increase the amount of stationary storage, which is critical because renewable energy is intermittent. Wind and solar is intermittent. Sometimes the wind doesn't blow, and obviously sun doesn't shine at night. So you got to have batteries, a massive number of batteries. So
it's hard to measure in direct impact, but it's an experiment that we shouldn't be performing. And the sooner we can sort of end the experiment, the sooner we can kind of move on in a fully sustainable way that is actually lower cost. I mean, I think the thing that people haven't fully internalized is once we do get to the 25K car, the ownership cost of that car is incredibly lower than the prior car. And then on the solar side and wind, with the cost of solar and wind coming down and with batteries coming down with them, the actual cost of energy on the grid is going down. So we're sort of moving towards a sustainable, lower cost future.
Okay.
So there's not really a sacrifice.
That's true. It is a false dichotomy to say that it's either.
Also der Umschwenk zur nachhaltigen Energiewirtschaft wird auch günstiger werden. Also auch der Strompreis von regenerativen Quellen wird halt günstiger werden. Und wenn die Batterien günstiger werden, werden auch die Autos günstiger sein als andere Autos, weil es halt viel einfacher ist eigentlich.
Sustainable energy is going to be lower cost, not higher cost than fossil fuels.
Elon, quick question for you, right here in front. First, thanks for having everyone, and is telling a friend the one company to go work for that's going to have the biggest structural impact over the next 10 years at scale, it's probably Tesla. So kudos to everyone at Tesla for what they've done to this point and going forward. The two questions for you, as you've looked at the auto and the storage markets, I know you've talked about it at kind of 50-50 long term, but it seems like a lot of the battery cost curve achievements that you've presented today really make some of these storage opportunities much more feasible over the next 5 years. And so I guess the first part of the question is, does your calculus upon learning and improving these things change on that 50-50 mix, or is there a role where storage becomes bigger? And then the second part of the question, with all these huge grand visions, who's going to be with Tesla from a corporate perspective accomplishing these things. Obviously, Tesla can't do it alone. But when you look at some of the traditional auto industry or power, etc., I don't see a lot of other Teslas.
Well, actually, so there's a lot of companies in China that I think are doing great work with electric vehicles and also with stationary storage. Although we don't see that much in the US yet, but I think probably we will in the future. I don't know. I mean, obviously, we're doing everything we can to encourage other companies to move to sustainable transport and also make stationary storage batteries. We opened up, made our patents freely available.
Okay, also er sagt jetzt, dass in China viele Unternehmen schon gute Elektroautos und auch stationäre Speichersysteme haben, aber in Amerika noch nicht so viel. Über Europa hat er jetzt irgendwie gar nicht gesprochen, das mal ausgeklammert. Aber er hofft, dass andere Unternehmen da auch mit einsteigen und halt diese nachhaltige Zukunft auch unterstützen. Ja.
The size of the market in terawatt hours, and they are roughly 50-50. 10 terawatt hours for transportation, 10 terawatt hours for the grid. And part of that is because the grid batteries, because when you're making a power plant, you're making a large investment, are 25-year assets or greater. If the grid batteries were 10-year kind of things, the grid market would be bigger, but because it's a longer duration asset, they're roughly the same size.
Thinking long term, is there any other segments that this new battery will be able to disrupt or electrify beyond just the initial Model 2 or cheaper sedan, like a boat, boring company loop?
Galileo Russell, oder?
Are you there? What's up? Right here.
Okay, great.
It's
like ventriloquism here, It's like we just get the sound out of the speaker and where the heck is coming from?
Hey, und Elon Musk erkennt Galileo Russell an der Stimme. Geil.
Because it decreases the cost of transportation, that is really the disruption, or should we get hyped that this new cost curve opens up different vehicle categories like a high passenger density bus, boring loop, boat, plane?
Well, I mean, there are batteries in limited production right now that do exceed 400 watt-hours per kilogram, which I think is about the number you need for decent range, medium range aircraft.
Okay, also Sie sind jetzt bei 400 Wattstunden pro Kilogramm, womit man wohl durchaus ein Mittelstreckenflugzeug hinkriegen kann.
Yeah, I mean, I think over
Da
time we'll see all
hatten wir vorher schon gesprochen.
with the ironic exception of rockets, transition to sustainability.
Genau.
Or to electric, basically.
Also er sagt, man kann jeden Transport elektrisch machen, aber ironischerweise halt keine Raketen, also die er halt mit SpaceX hochschießt, können nicht elektrisch quasi fliegen. Ja. Da geht es dann darum, halt den Treibstoff für die Raketen auch nachhaltig zu erzeugen, was ja durchaus möglich ist, wenn es nicht zu viel ist.
I have a question in regards to the lithium and nickel industries and the likely price spikes and shortages of high-grade materials the EV industry is likely to see if they don't act fast to address future supply. Tesla have clearly made the right moves that are necessary, but there's a real worry that the potential supply issues and price spikes will create a drag on the rest of the EV industry and therefore a drag on global EV adoption. What advice would you give to the EV and mining industries to quickly solve this looming hurdles? Because for a sustainable energy future, the spice must flow. Thank you.
Yeah, indeed. The spice must flow.
Okay, also es geht um Rohstoffe und wie denn das adressiert wird, dass die Fördermengen halt hochgefahren werden.
I'm not sure. I guess we can try to basically overdo it in cell production and perhaps supply cells to others. But we do see the fundamental constraint as total cell production. That's why we're putting so much effort into making cells.
Okay.
And kind of reinventing,
also er sagt nochmal, dass deren größte Limitierung halt die Zellmenge ist
a complete battery pack.
beim Herstellen von Fahrzeugen.
Because it's the fundamental constraint. We're not getting into the cell business because we, just for the hell of it. It's because it's the fundamental constraint. It's the thing that is the limiting factor for rapid growth. But we could certainly try to overdo it on cell production and perhaps sell cells to others.
Und eventuell wollen sie auch Zellen verkaufen an andere Hersteller. Aber er weiß es nicht so genau. Ob sie es nicht vielleicht alles selber brauchen. Kann gut sein, je nachdem, wie viele Fahrzeuge sie verkaufen.
Rolling resistance, efficient powertrains. I mean, that's kind of what we've done in order to make iron phosphate still have a good range. So the iron phosphate's lower energy density solution, but there's while there are some limitations on the total amount of nickel produced every year, there's really no limit on the iron. There's so much iron, it's ridiculous. So you can really scale up iron phosphate, at a raw materials basis faster, more than you can nickel.
Genau, und das war auch ein Grund, warum die jetzt diese LFP-Akkus, also Lithium-Eisenphosphat-Akkus, haben, weil Eisen ist einfach mehr oder weniger unbegrenzt verfügbar, im Gegensatz zu Nickel und Mangan, was sie für die anderen Zellen brauchen. Ja.
We can do a lot to extend the range of an iron-based vehicle, which is why it's a key part of the roadmap going forward. And then I invited Turner up here to talk about what the mining industry can do.
Yeah. Diversification on the cathode side is obviously massive, and EVs are all about efficiency. And so for the EV industry, for the vehicle industry, we need to see powertrain efficiency really increase at all other companies matching Tesla powertrain efficiency so that everyone can have that diversified cathode approach where LFP is used in medium range and even really make a 300-mile vehicle.
Bernie. Ja, sehr gern gemacht. Wie gesagt, ich hatte das eigentlich nicht vor. Das hat sich so ergeben. Auch aus dem Chat wurde halt danach gefragt und wie gesagt, bin kein professioneller Übersetzer, aber hab's versucht, so gut wie möglich zu machen.
The process path from mine to cathode. And what we're doing here is novel, and we're trying to push the industry in that direction. So we're presenting a model here that anyone can follow.
Yeah, in fact, if there's anything that you guys want to comment on, feel free to step forward and say something.
I think the key is to be smart about your chemistry choices, your materials choices. Yeah, if you're smart about your materials choices, the spice will continue to flow. Yeah. You don't need to use the same kind everywhere. And it's about strategically planning it out. And for miners, I think we are incentivizing them quite a bit to ramp up their production.
Yeah. And actually we had good calls. Like they're all motivated. I think that they've been sort of sitting back being like, are you going to grow like crazy? And we're like, yeah, we're going to grow like crazy. And I think this indicates we're going to grow like crazy, and that's what the miners want to hear, and then they'll go make investments.
Also sie haben jetzt auch mit den Minen oder den Leuten, die halt die Rohstoffe fördern, telefoniert und die wollen da auch mitmachen bei diesem Hochlauf auf diesen 3 Terawattstunden.
Expand your services for artists and other types of creative people to get involved in producing content that can be part of the Tesla ecosystem, or so other people that do creative things can get involved with you guys?
Well, we haven't really thought about that much, but I suppose it's probably something we should think about. We will be providing titles on Teslas. So, we're providing, more music sources that people can choose from, and just generally trying to improve the entertainment experience in the cars. And I think actually, as we go to a more autonomous future, the importance of entertainment and productivity will become greater and greater. I mean, to the degree that if you're just basically sitting in your car, the car is fully autonomous and driving somewhere. It's sort of like being in the car is essentially your chauffeur, and then the things that become important are, okay, well, let's have good entertainment, and if you want to do some productivity stuff, then that actually starts to become much more important because you're no longer spending your attention driving the car. So it will be extremely important in the future.
Should we do some of the say.com questions? Okay.
Aber war jetzt eigentlich dieses Plaid Model S das One More Thing oder
Yeah,
kommt da
the
jetzt
first one
noch
we already
eins?
answered. Like if we're able to make enough sales, which we'll try to do, or we will supply other companies. It's definitely not an intentional effort to keep the sales to ourselves. If we can make enough for other companies, we will supply them. And we're trying to do the right thing for advancing the sustainable energy, whatever that is. So vehicle to grid, we get asked that a lot. I think one of the things that's important to note is the vehicle to grid. It doesn't, unless you have a power cutoff. Like you need to cut off your main supply to the grid. Otherwise, if you lose power in your house, you'll basically just backflow energy to the grid. So just having a reversal in the power flow does not actually keep the lights on. You need a whole separate system to cut off power to the grid. And I think it's also the case that people really want the freedom to be able to drive and to charge at their house. And it's obviously really problematic if you get to morning and your car, instead of being charged, it discharged into the house, and then you're sort of, okay, now I can either drive or use the battery to power my house. I think it's actually going to be better for people's freedom of action to have a power wall and a car separate. And then it's
Das sehe ich anders. Also er hat jetzt gesagt, es ist besser, eine Powerwall und ein Fahrzeug separat zu haben, anstatt das Fahrzeug als Hausspeicher zu benutzen. Aber das sehe ich anders. Also ich sage mal, wenn ich einen 100 Kilowattstunden Akku habe und davon oben irgendwie 20 Kilowattstunden fürs Haus benutze, was ja dicke reicht, wäre es super. Also da stimme ich nicht zu.
I think we could basically enable that with software in Europe or something, right?
Yeah. We are future generations of power electronics. We will be able to do this more or less everywhere from a energy market participation perspective. But yeah, from a backing up the house, and it just so happens that the way the North American connectors are on all the cars in North America, it doesn't matter whether it's the Tesla connector or the connector that the other vehicles have, doesn't actually support powering your home. It's unfortunate. So you need an additional hardware to do that. But yeah, in the future, all versions of our vehicles will be able to at least do bidirectional power flow for the purposes of energy market participation. But even for that, it's important to remember that your car isn't plugged in 24/7. So it's kind of an unpredictable resource for the grid. It'll have a value, but it's not the same as a stationary battery pack.
Yeah, honestly, a vehicle to grid sounds good, but I think actually has a much lower utility than people think. I think very, very few people would actually use vehicle to grid. And we actually had with the original Roadster, we had vehicle to grid capabilities. Nobody used it.
Yeah. How do we find the engineers to do everything we're saying?
How do we find the engineers to do all these things? I guess we recruit a lot of engineers from all parts of the world. I think Tesla has a good reputation for doing exciting engineering, and that tends to attract a lot of the top engineers in the world because they know that their efforts at Tesla will really serve the greater good. And we're super hardcore about engineering. Tesla is first and foremost an engineering company. It's hardcore engineering is what we do. The sheer amount of hardcore engineering done at Tesla is insane. And if you look at, say, there's various surveys done of engineering schools, where do you want to go? What's your top choices? And actually, the top two choices
Tesla and SpaceX.
Last few years have been Tesla and SpaceX. So sometimes it's Tesla first, sometimes SpaceX first, but those are the two top ones.
Yeah, I mean, if you are motivated to solve some of these problems, which are the hardest problems in the world to solve, that really fundamentally enable the future we all need, please reach out.
Yeah, and
help us work on these problems.
Absolutely, and like you said, the battle is far from over. Less than 1% of the global automotive fleet has been converted to electric, and even maybe less than 0.1% of stationary storage has been done. So stationary storage has barely begun. Converting the global vehicle fleet to electric has barely begun. So there's still a massive amount of engineering work to be done at Tesla and other companies to accelerate this transition to sustainability.
Hey, can you guys hear me?
Yeah.
This is Jordan from Mark Asset Management. So you've talked about the importance of the factory, and you've mentioned the ground-up design process and a lot of the new things that you're going to be doing or started to do in Shanghai, Berlin, and Austin. Can you just maybe help us understand and quantify like how financially meaningful all of those improvements will be? And then given what you're trying to accomplish as a company, is it fair to assume that the vast majority of improvement will be given back to the customer in the form of lower prices?
Yeah, I mean, I think certainly we will try to give back as much as possible to the customers. It's not like, it's not like Tesla's profitability is crazy high. Our average profitability for the last 4 quarters is like maybe 1%. So just to be clear, it's not like, we're minting money. Our valuation makes it seem like we are, but we're not. So we do want to try to make the price as competitive as we can without like losing money. And if you lose money, then if you keep losing money, you'll just die. So we have to this thing called profit, just like we need to bring in more money than we spend, otherwise we're dead. So,
but affordability is key to how we scale, right? Like the demand goes nonlinear as you reduce the price of the car.
Yeah, I mean, it's important to sort of separate the difference between affordability and value for money, or desirability of the product. So, for a lot of people, they want to buy a Tesla, they simply don't have enough money. We could make the car infinitely desirable, but if somebody does not have enough money, they can't buy it. Sometimes, people, kind of forget this. It's like, it's like people have to have enough money to buy the car. And just making a car super desirable but expensive does not mean they can afford it. So it's absolutely critical that we make cars that people can actually afford. Yeah. So we should go some of these things. Scroll down or something. Oh.
When do you expect Tesla vehicles to beat ICE vehicles on initial purchase price? I think a way to answer that question is, in the classes of vehicles we sell today, we're already doing that.
Yeah, we're already pretty close. And then factoring in total cost of ownership, the fact that electric vehicles require much less servicing, and are way cheaper to run. When you look at like total cost of ownership, and you can obviously lease a car. So if you just like lease a car or get a loan for a car, you've got your sort of monthly payment, and then your cost for either gasoline or electricity, and your cost of servicing, and the fully considered cost of an electric car is much less than a gasoline car of the same nominal purchase price. I mean, that said, and like maybe on the order of 3 years, when we can do a lower cost car, like a $25,000 car, I think that will be basically on par, maybe slightly better than a comparable gasoline car. So I think maybe it's on the order of 3 years ish.
How have the technology advancements and increased vertical integration of battery manufacturing influenced your ability to improve the environmental and social impact of the supply chain? And I think, yeah.
I think we sort of have said that already.
Yeah.
Do you have some ability to scroll through this? I just scroll away.
We covered recycling.
Yeah. Well, just scroll until we've got stuff that we haven't covered.
Well, we definitely covered that top one.
A lot of these things we've already answered, I think.
Covered that. That one. I think we
literally just answered that.
Yeah. Oh, I saw a cathode durability question. Let's go to that one. Go down, go down, go down. Good technical question. Keep going. How are you going to address the cathode durability and cost and environmental impact trifecta? Is this something you're going to leave the upstream supply chain to solve? No, I think we tried to answer that directly. I mean, we really are looking at not just what happens in the cathode facility, but like currently outside the cathode facility that should really be inside, and removing processes that shouldn't have been there in the first place, and the use of reagents that are just costly and not necessary, and removing a bunch of wastewater from the process.
Guys, is there anything you want to add to? Maybe we could like go through everyone and like maybe say what you're doing and say a few words. I don't know.
Sure. I just want to reiterate the fact that this is a massive problem.
Massive problem.
And it seems like Tesla's on its way and ahead, but we need everybody's help because it's everybody's planet, and we're not going to get to 20 terawatt-hours by ourselves. So please think about this carefully as it affects everybody. So let's get on it.
And obviously, if you care about solving sustainability and doing hardcore engineering, definitely come work at Tesla.
Yeah, we went through a couple of the manufacturing improvements, and it kind of looks easy when you put together a nice slide deck, but the challenges are like this. It's super challenging when you take materials out of the process, when you integrate processes together. You have to do a lot of things at once, and that's like this immense engineering challenge. And so like, to appreciate that, like you need like to get through this, we need like the best engineers we've got, and we've got this awesome team. I just want to shout out also to all of our team watching, like you guys are awesome. Like you absolutely kicked ass putting this together, and yeah.
Yes. Thank you.
Thank you, Tesla team. Totally agree.
Yeah, that's it. Like, yeah.
Okay. Yeah. Rodney Westmoreland, managing the construction here at Tesla. What I would like to say is one, shout out to the team. The team has been working effortlessly. A very, very tough project here for 24 hours a day, it seems like, around the clock to have this complete. The thing that sets us apart from a lot of other construction, we have a construction company here. The thing that sets us apart is that we're integrated in the manufacturing process. So every detail that comes from Drew's mouth is directly implicated into the system that we're building. That way, what would typically take 3 or 4 months to create a specification, our design team is working right with the manufacturing team to allow us to speed that process up tremendously. So.
Yeah, it's definitely a important part of the vertically integrated approach is to be able to design the factory around the equipment, in fact, together with the equipment, so that you can build the factory at lower cost and more quickly.
Yeah, I'm Scott. I focus on cell design. I think it's hard to put into words how inspiring this is. I've been at it for a long time with Tesla, and
yeah,
I really hope others do join us.
Since when, Scott?
Since 2005. Yep,
yes,
with many of you. But thank you. It. Yeah, year before Drew, but who's keeping track? But I'm really stoked at what the team's been able to accomplish over the last, short period of time, about a year. It's been really an incredible transformation. I mean, hopefully what we've shown you inspires you to join us or join somebody else in the effort. And I couldn't think of a greater, more intelligent, more hardworking team to be working on with this problem.
Hi, Peter. I lead the manufacturing improvement team. And I guess the point that I would like to make is manufacturing improvements is like the accelerator. So like you think about the execution that Rodney talked about in terms of how fast we've been able to put together this factory, which is amazing and something that's been really incredible to be a part of. That's not enough. What we need to do is improve the manufacturing technology. That's the real accelerator. And that's what we're really focused on. Elon talks about it all the time, that really going and improving that system is what will enable us to get to the scale and the cost that we need. And then the other point that I would make is on the recruiting side, like it doesn't matter if you know about batteries. If you come from any industry, you can do something fantastic in the work that we're doing. We talk to people from industries that you wouldn't imagine. Like I talked to a guy who makes golf balls, and he has stuff which is really impactful for what we're doing. So, if you're in any industry and you want to be, impactful here, like come join us. It'd be great.
Hi, excuse me. Hi, I'm Tony. I've been working in lithium and cathode materials for almost 23 years now. And this is the most growth I've seen in a company. I've been here a little over a year and a half. We're hiring amazing people that are allowing us to leverage technology that most of the industry is struggling to achieve. So to answer the question, how are we going to do this? We are really advancing the materials manufacturing for cathodes and for lithium beyond what has been accomplished in the previous 20 years.
It's exciting.
Yeah, my name's Turner. Work closely with the team. I've worked a lot with everyone here, and on the cathode and upstream materials side, it's really important that everyone understand that this growth is coming. This growth is real. We are going to make all of these batteries, and everyone needs to grow with us. The entire supply chain needs to grow with us. And if you have an idea that simplifies anything in the supply chain, come talk to us, come work with us, and let's do it.
Any existing specification is wrong. Any existing manufacturing method is wrong. Process equipment, it's wrong. It's just a question of how wrong.
Yes.
Quote
Exactly.
Elon Musk.
Yes, exactly. We're wrong. Just a question of how wrong. There's going to be less wrong.
So tell us how we're wrong and how we could do it better, so that we can accelerate and improve as fast as
Nee,
possible.
ich bin noch nicht im Bett. Aber ich habe jetzt hier gerade mal meinen Popcorn geleert. Und
hope you like the presentation. Very exciting future
Ja.
ahead. We're going to work our damnedest to transition the world to sustainable energy as quickly as possible. And your support and help is key to that success. So thanks again. Super appreciated.
Jetzt mal gespannt, ob da noch
Next
ein...
event. Thank you.
Thank you.
Ja. One last thing kommt oder ob es jetzt wirklich zu Ende ist. Also ich meine, es waren ja wirklich wahnsinnige Verbesserungen in den Akkus, also Kostenreduktion 56%, hammerhart. Ja, aber das werde ich morgen alles mit dem David in Ruhe nochmal besprechen. Da machen wir ein ausführliches Video zu, es kommt dann hier auf dem Kanal. Ne, also jetzt scheint es wirklich aus zu sein. Und ja, ich danke euch, dass ihr zugehört habt und dabei gewesen seid. Es waren ja zwischenzeitlich tatsächlich deutlich über 300 Leute. Ziemlich cool. Und ich weiß auch nicht, will der David da jetzt noch mal kurz...
Hi, kannst du mich hören?
Ja, wolltest du noch was sagen für alle oder sollen wir jetzt erstmal nur wir zwei quatschen?
Ja, ich bin ziemlich platt, ehrlich gesagt. Das war echt
ja,
heftig.
ich auch. Genau. Also,
aber schön, dass doch ganz schön viele eingeschaltet haben noch, habe ich gerade gehört. Ne?
Ja, es hatte sich irgendwie schnell rumgesprochen, dass ich ein bisschen Deutsch übersetze und dadurch sind halt viele dazugekommen und haben sich auch ausführlich bedankt.
Ja, cool, ich habe da hohen Respekt für. Ich hätte es mir nicht zugemutet, glaube ich. Das hätte ich mir nie zugetraut, das selber zu übersetzen direkt. Also
ja, waren sicherlich einige Lücken drin, ist auch schwierig, wenn gleichzeitig jemand quatscht und so. Aber naja, ich glaube, einige haben dann doch einiges verstanden. Und
ja,
genau.
Cool. Ich habe mich zwischenzeitlich ausgeklinkt, damit ich den englischen Text komplett hören kann. Und ich denke, wir besprechen einfach alles dann morgen ausführlich.
Ja, genau, so hätte ich es jetzt auch gemacht und dann machen wir morgen dann das ausführliche Video. Wenn wir es hinkriegen, dann morgen schon zu veröffentlichen, dann könnt ihr das alles nochmal zusammengefasst und auch auf Deutsch euch dann anschauen oder anhören. So rum, da bei David von der Tesla-Welt, also vom Tesla-Welt-Podcast, könnt ihr auch in eurem Tesla einfach suchen und hören. Genau. So, und dann würde ich sagen, machen wir mit dem Livestream jetzt mal Schluss. Es ist ja zu Ende. Und wie gesagt, kommt dann morgen ausführliches Video und halt deine mittwöchliche Podcast-Folge, die jeden Mittwoch kommt, dann eben diesmal zum Battery Day. Okay,
genau.
Also danke an alle,
die später als sonst, aber wir kriegen es hoffentlich hin.
Ja, genau. Also danke an alle, die dabei waren. Hat mich gefreut. Und genau, jetzt gehen wir erstmal schlafen. Ist ja doch schon recht spät. Also, ciao.
Ciao.